Hello and welcome to How to Make an App for Beginners. In this video, I'm going to show you how to make an app even if you've never programmed a single line of code before. Now, by the end of these next 10 lessons, you'll have built these apps and user interfaces. And I'll also show you how to put them on your phone so that you can show your friends and family. But more importantly, I'm going to teach you the fundamental skills that you'll need to build any sort of app. So by taking these beginner lessons, you're going to get a really nice and solid foundation in iOS app development. From there, you'll want to grab my free 7-day app action plan where you can create a customized app roadmap just to build your app. You also want to join our active Facebook community where you can get help and support from myself and the team and tons of other people learning iOS just like you, so that you're never stuck or alone on your journey to create apps. Now, the last time I taught this, it was viewed by over 1.2 million people and tons of success stories came out of it. A ton of people created their own mobile apps, as you can see some of them on the wall behind me. Now, I know that's all going to come for you too, but it all starts right here, right now. Are you ready? Let's do it. Welcome to Code with Chris, the place to be if you want to learn how to make an app. I'm Chris and I'm so glad you're here. First things first, how do you create an app from scratch? Well, it all starts with a program called Xcode, where you design the user interface for your app and write your code. That gets turned into an iPhone app, which you can publish to the App Store where millions of people can download and use it. Before that, let's backtrack a bit though. Xcode is a program you can download for free, and the code I'll be teaching you how to write is called the Swift programming language. Don't be intimidated if you've never coded before, because I guarantee you'll get the hang of it. Next, Xcode can only be installed on Mac computers, but if you don't have access to one, you do not need to spend thousands of dollars to buy one. Instead, check out my video on Xcode for Windows using Mac Stadium first. Alright, so with that out of the way, let's dive in and let me show you around Xcode. So the first thing you're going to want to do is to download Xcode if you haven't already. And all you have to do is hit Command Spacebar on your keyboard to launch Spotlight, type in App Store to launch it, and then in the search bar, type in Xcode, and that's going to find it. Now, I've already got it installed, so if you don't, you want to go ahead and do that. I'm going to warn you though, it's a pretty big application, so it does take a little while to install. And if you can't, if it gives you an error message or something like that, scroll down, check on the compatibility. If you click it, it tells you what version of macOS it needs. For this one, it needs 10.13.6, but whenever they upgrade Xcode, this number gets higher and higher. So you might have to update your version of macOS in order to install Xcode. Also keep in mind the size here. Even though it says 6.1 gigs, it sometimes needs a little extra space in order to do the installation. So once you have it installed, go ahead and open it. You're going to be greeted with a dialog like this. What we're going to do in this video is create a brand new Xcode project. So click on Create a new Xcode project. If you don't see that dialog for some reason, maybe you've launched Xcode before, you can always go up to File, go to New, and choose Project. And that's going to get you to the same place. Now there's a bunch of different templates that you can start with to help you just be a little quicker in terms of what you want to create. What we're going to want in this lesson is to be under this iOS tab, because there are different platforms you can build for using Xcode and Swift, which is the great thing about learning these two things. But we're going to do iOS today, and we're going to choose single view app, and that's going to give us our basic one-page app or one-screen app. Next, we're going to want to configure some of the options for our new project, such as what the name is, what the unique ID of it is. And for the product name, you can name it something. I'm going to choose Hello World, like that. The team dropdown, you might not have a team here, and that's not going to matter right now, but you will want to create a team when it gets to the point where you want to put the app on your actual device. And I'll show you how to do that later on in the series. Organization name, I would either put your company name or your personal name. And then what's common under organization identifier is com dot and then your name or your company name. So combined with the product name, that's going to be the bundle identifier. You're going to see this term used quite a bit. It's basically like the unique ID for the app that you're creating. When you publish your app or when you upload it to the App Store and that sort of stuff, you're going to need that bundle ID. Okay, so next, very important is to make sure your language is set to Swift, because that's what we're learning here. You can leave these guys unchecked and then click on next. And you can also leave source control unchecked as well. We're not going to go through that right now. Go ahead and click create and you're going to have your brand new Xcode project. Now it kind of looks intimidating because there's all these checkboxes and drop downs, and this interface to someone who hasn't seen it before is pretty confusing, but I'm going to walk through it with you right now. And I also have a reference sheet for you with a diagram and all the keyboard shortcuts for Xcode, so make sure you grab that in the description below. So we're going to start on the left-hand side of the interface, and this is the navigator area. You'll notice across the top that there are different tabs that you can click. It might not be so clear in the beginning, but these are different navigators that you can choose. By far, the most common one you'll be using is this project navigator, where you can see all of the files in your Xcode project. Now, clicking on any of these files will change what's in the middle. That's called the editor area. So for instance, right now we have this first project file clicked on, and that's why we see all of the project properties in the editor area. If we click on viewcontroller.swift, you're going to see that this turns into the code editor so that you can write Swift code. Go ahead and click on main.storyboard, and this is going to change into an editor where you can customize the screen for your app. We're going to be doing this shortly. This is actually called Interface Builder, so you can kind of get why that name is the way it is. Next, let's go to assets.xc assets. This is where you're going to put all of the images for your project that you're going to use. And then launch screen.storyboard is another sort of interface builder file where you can customize the launch screen. And then the plist has some further properties for your project. So at a high level, those are the files that by default are included inside your Xcode project. Now moving along to the right side of the screen, we've got the utilities pane. And what you see here depends on what you're clicking on inside of the editor area. So it's like a further drill down. So for instance, if we go into the main.storyboard and I click on this white area, which is my view or my screen, it's going to show me further details about that. And in the view controller.swift, if I click on, let's say, some piece of code, then it's going to tell me something related with that. But keep in mind that, again, there are some different tabs with this utilities pane, as you can see up here. So if we go into the main.storyboard, you can see that there are a couple more tabs, and that's because I can configure properties for this element. So it looks like Xcode has experienced an internal error, but usually these are fine. You can just close the project and relaunch it. I'm not going to do that right now. It's fine. Across the top of the interface, you have your Xcode toolbar. Now on the left side of the toolbar, you have some buttons to run your project and stop your project. And then to the right of that, this is actually a drop down where you can select the destination on which to run your project. Now, if you plug in your phone, you can actually select your phone from that drop down. But if you don't have a phone plugged in, don't worry, because Xcode has a bunch of simulators where you can run your project on, and it's going to show it on the screen. We're going to do that in just a second. In the middle here, you have your status bar. It's going to show you what's going on with your project, what it's doing right now. And then on the right hand side, there are a couple of more controls here, which we're going to get to in a second. But in the rightmost part of that toolbar, you're going to see these buttons, which are really helpful to you right now. It's just to hide and show these different areas that we're talking about. If you click this middle one, you'll notice that it brings up this little tray down here that we really haven't talked about yet. And this pane down here is called the debug console. And when you're running your project and let's say an error happens, you're going to get some details about that error in this debug console. So by default, it's hidden. If you want to show it, all you have to do is click this button to bring it up. So these are the major sections of the Xcode user interface. It's not that complicated once you know, right? What we're going to do now is go ahead and run our project on a simulator. So in that drop down that I showed you, by default right now it's iPhone XR. You can select any one you want to try out and just click this big play button right here. It's going to launch the iOS simulator. Now the first time you do this, it might take a couple of minutes, but then subsequent times it's going to be a lot faster after the simulator has launched. So you actually don't really need a physical iPhone device. If you don't have one, you can still build and test your app. Now there's one quick thing I want to mention, and that is if your simulator is way too big for your screen and you can't see all of it, you can actually scale it down. So you can either go up to the menu of the simulator and choose, physical size or point accurate or pixel accurate. You can use these shortcuts, Command 1, Command 2, or Command 3 to change the size of the simulator that you see. So just a handy tip for you in case the simulator is way too large for your screen. So when your app has launched, you're going to see this white screen, and that's because we haven't really added anything to our app yet. But before we do that, let's talk about how that Xcode project turned into this app that I'm seeing in the simulator. This top layer is the view. It's the screen that the user sees. Now you can configure this view from the main.storyboard file in your Xcode project. The second layer under that is called the view controller. Now this code file is responsible for managing the view. For instance, when the user taps on the view, it's going to let the view controller know, and then you can write code inside that view controller to handle that tap, to either run some process in the background or maybe display some new information on the screen. You get the idea. Now this view controller is represented by the viewcontroller.swift file in your Xcode project. And as we said before, if you click on that file, the editor area turns into the code editor where you can write Swift code to manage the view. Now if your app has multiple screens, in most cases, each screen is just going to have its own view and view controller. Now let's go back into Xcode and we're going to stop our project and we're going to add something to the view so that there's something to see. Let's hit on the stop icon right here and then click on main.storyboard so you're seeing the interface builder. And now I'm going to introduce you to this button here called the library button. So if you click this, it's going to bring up a list of objects or UI elements that you can add to your view. Type in label to search for this guy, and all you have to do is click and drag it onto your view like this. Now you're going to see that label on your view right here. Now you can drag it around and you can position it, but that's not really going to do anything because Xcode actually has its own way of positioning and sizing layout items. Xcode uses a system called auto layout to position and size the elements on the screen. This system makes it easier for you to design a single interface that looks good on iPhone, iPad, and all the other screen sizes of future iOS devices. Now, basically, all you have to do is specify a list of rules for each element that dictates how it should be positioned and how it should be sized relative to other elements on the screen. For example, this element should be the same height as this other element, or maybe this element should be centered on the screen. These rules are called constraints, and in lesson 2 you're going to learn a lot more about auto layout and auto layout constraints. But for now, let's jump back into Xcode and take a look at how we can position and center our label on the screen. Alright, so back in Interface Builder, I want you to select your label just to make sure that it's highlighted, and then down here there are a couple of buttons where you can add auto layout constraints. So click on not add new constraints, but this button called align, because we want to basically align this label in the center of the screen. So we're going to check horizontally and vertically in container and then click add to constraints. And you can instantly see these lines here that represent the constraints you just added, as well as the label being centered on the screen. If you've made an error, don't worry, check it out right here. This is called the document outline, and it basically shows you all of the elements and all of the constraints that are in your view right now. So just open up constraints. You can highlight your constraints that you've added. Maybe you've made an error or something like that. You can either delete them right now. I can hit delete and get rid of them, or if you highlight them in the utilities pane on the right hand side, in this size inspector, or there's different inspectors that you can select. Make sure that you're looking at either the attributes inspector or the size inspector, and then you can edit some of the properties for your constraint. I'm going to show you just deleting them right now off of the document outline, so they're gone. And I'm going to do it again. So you can hit your label now and you can go into align and select horizontally and vertically in container and then add two constraints like that. The next thing we're going to do is we're going to edit that word inside the label. So make sure your label is highlighted, and then on the right hand side, again, make sure you're looking at the attributes inspector right here. Under text, you're going to be able to just type in whatever you want. I'm going to type in hello world and voila. So click on the run button on your Xcode project and it's going to launch the simulator once again, and you should be seeing something that looks like this. Congratulations, you've built your first app. To get a copy of the recap notes of what we went over today, as well as some practice exercises, just click right over here or find it in the description below. In the next lesson, you're going to be building this in Xcode. Hello, in this video, I'm going to teach you how to build user interfaces for your apps using Xcode's auto layout system. Now, if you want to know how to build cool UIs like these, then the auto layout basics I'm going to teach you in this lesson are absolutely critical to know. And if you watch all the way to the end, you're going to have a really good idea of how to build your own user interface for your own apps. Does that sound good? Let's do it. All right, so let's pretend that we have to build a login screen for our app. We're first going to start by doing it the old way, and then we're going to jump into Xcode and use auto layout and do it for real. Now, our first task is to place the logo on the screen. Xcode uses an XY coordinate system where 0x and 0y is in the upper left corner. So this point would be 0x and 0y, or just 0, 0. Next, take a look at this red dot. This represents a location on the grid at 10, 10. So you kind of get the idea. If you specify a logo to be placed at this point at 10, 10, then it's going to take the upper left corner of that logo and put it at that point. Now next, you can specify a height and a width for that logo, and that's going to adjust the size of it. Now together with the X, the Y, the width, and the height, that is called the frame of that logo element. Now you can continue to use this approach and place the rest of your labels, text fields, buttons, whatever you need. However, when the login screen is shown on a much larger screen, it's not going to look the way that we expect. And this is where auto layout comes in. So instead of specifying exact X, Y coordinates, widths, and heights, we specify rules to describe the location and sizes of all of the elements relative to other elements. And these rules are called constraints. Now, why don't we try redesigning this login screen using auto layout constraints instead? So here's our first login button. I'm going to add a constraint to say that the horizontal center of this button should be the same as the center of the view in terms of the x-axis. So that is going to center it on the screen on that x-axis. Now I'm going to add another constraint to say that the button should have the same vertical center as the view, and that's going to center it vertically on that y-axis. Now this effectively puts the button right in the center of the screen. Next, I'm going to add the logo, and I'm going to add a constraint to make its horizontal center the same as the horizontal center of the button. So that's going to align the two elements like this. I'm going to add another constraint to that image, and this time we're going to say that the bottom of that image should be 20 points above the top of the button. Now notice I said points and not pixels, and that's because in iOS we have devices with different pixel densities. So for example, on the original iPhone, 1 point is 1 pixel, they're one and the same. But then Apple introduced Retina screens where they managed to squeeze 4 pixels in the same amount of space that used to be 1 pixel. So on these screens, 1 point is equal to 4 pixels. And then Apple introduced the Super Retina screens, and these are for the plus-sized iPhones, where they managed to squeeze in 9 pixels in the space that was once 1 pixel. And so 1 point on these screens equals to 9 pixels. So that's why when we're designing our user interface, we always speak in terms of points. It allows us to have a consistent user interface regardless of the pixel density of the screen that it's being presented on. So when you say 20 points from the left side, it's going to look consistent on the original iPhone, on a Retina screen, or a Super Retina screen. Now, if this is kind of confusing to you, don't worry, because you're never really going to have to worry about how many pixels things are. You're always working in terms of points. But I think that it's important that at least you know about this distinction. Now, another thing I want to point out is that if I don't specify a specific height and width constraint for this logo, then it's going to just be set at its intrinsic size, which is just whatever size the image is. If you wanted to, you could add constraints for the logo to make its height and width relative to other elements or even relative to the screen size, but I'm just going to leave it as is. Now I'm going to do something similar with the second button that we're going to add. I'm going to add two constraints, one to say that it has the same horizontal center as the first button, which is going to align the buttons together. And then I'm going to add a second constraint to say that the top of the second button should be 10 points below the bottom of the first button, just so that they have a 10-point gap. Now we're going to add the last button, two constraints again, one for the horizontal center and the second constraint to position it 10 points below that middle button. Since all of these elements have constraints that are relative to that first button, if I move that first button around, then all of the other elements will follow, because the auto layout system is going to find a way to satisfy all of the constraints that you have added. Now there's a much easier way to achieve the same thing that we have here without having to specify so many constraints, and I'll show you how to do that in lesson 3. For now though, I think it's important for you to understand how auto layout constraints work, which is why we are doing it this way. Now let me ask you, do you feel like being a bully today? Because we're going to be really mean to this logo right now. Why don't we add another constraint that contradicts an earlier constraint we added? So let's say that we add another constraint to this logo to say that the bottom of the logo should be 10 points from the top of the first button. Now notice that this contradicts the earlier constraint that we added that said that it should be 20 points above that first button. So there's no way that it can satisfy both of these constraints that we've added. This is called conflicting constraints, and the system will actually choose a constraint to break, and this can lead to unintended layout glitches. So the tough part of working with auto layout is just to make sure that you don't have conflicting constraints. Because sometimes as you're adding these constraints inside Xcode, you might lose track of what you've already added, and when you finally run your application, you might get a bunch of conflicting constraints, and the auto layout system will choose which ones to break, and the layout's not going to look like anything you intended it to. Now, Xcode does give you tools to help you manage and resolve these conflicting constraints, as you're soon going to see, because the next thing we're going to do is we're going to jump into Xcode right now and construct this login screen for real. Now, there's one thing that I want to quickly point out, and that's when you start your Xcode project, you don't have to turn on auto layout or anything like that to use it. In fact, it's just the standard. When you start a new Xcode project, you're going to be able to just start using it right away. So I've got a brand new Xcode project here using the single view application project template. If you're not sure how to start a new Xcode project, then I would say watch lesson 1 as we go through that in that lesson. What we're going to do is jump into the main.storyboard, and we're going to get started. We're going to hit Command Shift and L, and that's going to pop up the object library menu, or you can just click on this guy up here. And you can search for button here, click and drag it right there, and to add a button on the screen. And I want you to click on this align menu and choose horizontally center in container and add that one constraint. That's going to center that button, but you'll notice that there are some red lines above and below that button, and also in the document outline here, you'll see this red arrow. If you don't see this document outline, just click on this little icon here to open and close it. So anyways, I want you to click on this red icon, and it tells you that the system doesn't know how to position that button on the vertical axis because there's no constraints to dictate how to position it. So I want you to, and you can see here the category for the error is missing constraints. Now go ahead and click back. But just before we add that constraint there, I want you to notice another thing, and that is to click the button, click on this align menu, and don't be alarmed that this horizontally in container item is not checked. But you might ask, we just added that, why is that not checked? Well, the reason is because these menus down here are purely for adding new constraints. It doesn't consider what constraints are already been added to that element. In order to see what constraints you have added to that guy, you can either click the button and go into the size inspector, and you can scroll down a little bit under constraints. You can see that we have this align center X constraint, or you can open this part up in the document outline and you can see that we have this constraint. In fact, if you highlight that constraint right now, I want you to go over to the attributes inspector and we can take a look at the anatomy of a constraint. The main things that you need to notice is that an auto out constraint relates to one element, which is the first item, and how it is going to be related to the second item, in which case here it says superview.centerX. So what the superview means is it's just the view that contains that particular element. In this case, that is going to be our overall screen or our view. And so the button's superview, or another way to think of it is parent view, is the view, the screen itself. And the properties it is relating is the center X, right? So the button center X is equal to the super view center X, and effectively that centers the button on this screen right here. And then you can also play with things like the constant, priority, and multiplier, and these just gives you a couple of different ways to manipulate how it is related to that second item in that constraint, but we won't go through those right now. So go ahead and highlight your button. Let's add that positioning on the vertical axis. Click on align right here, click on vertically in container, and boom, right there. You'll notice that we have two constraints now for that button, and if you click on this button and go back to the size inspector, you're gonna see that second constraint there. So this is a handy way to see all of the constraints that are related to that element, because in here, this menu, this can get quite long once you have many items on the screen. All right, so that's going to represent our first button. We're going to add a couple more now. So go either use the shortcut key to open the object library or click on the button up there. Then add our second button, click on align horizontally in container, and we're going to have this second button relative to this first one by 10 points, right? We're going to leave a 10-point gap there. So click on this button and then click on this add new constraints menu, and it's going to have a couple of margins that you can set for, to be exact. You can enable or disable any of them. Just take note that if you edit one of these margins, that's automatically going to turn on that constraint. And then you can see it says add one constraint here. So I want you to pull down the menu and you can see for this button that you're adding the constraint to, what do you want that second element, you know, the one that it's going to be relative to, what do you want that second element to be? Since we want this button to be 10 points below this first button, we're going to make it relative to that first button, right? So that's why you got to pop open this menu to make sure that this is selected. So when you select that, it's going to change the value to what it currently is. So currently it's 33.5 points away. So just take note of that, right? For example, if we did view and we did, 10 points away, that would actually make this button go all the way up here and be 10 points to the 10 points from the top of the view, right? Which is not what we want. So make sure you have the right element selected and click add one constraint. And you can see there that constraint that we added right there. This button's top is equal to the first button's bottom, and the constant is 10. So that's where the constant comes into play. Now, if this is starting to get confusing because they're both named button, what we should have done to make it a little more clear is we could have renamed things like that. Let's say first button and second button, and now you can see the auto layout constraints, they change the names too, so that's really handy to see. Now if you click on this constraint that we just added, see second button's top is equal to first button's bottom by 10 points. So that makes a lot more sense. Now let's add our last button right here. Again, we're going to align it first horizontally in container, and we're going to add a new constraint, and we are going to click enable that top one, and we're going to make it relative to the second button by a factor of 10 points again. Boom, that lines it up right there. Let's not forget to name this guy our third button. So we've got our bunch of buttons there. Now, we're going to put a logo, but the logo is just going to be a text label in this case. And we're also going to add a little prompt, a little instruction label above these buttons actually. So let's do that. Press pop it open again. I instinctively know what the keys are, but my hands know, right? But then if you ask me to tell you, I have to look down at the keys first. So Command Shift and L. And that's actually one thing that, now that we're on this topic, I want to tell you about is just muscle memory, right? So, you know, at first when you're learning this stuff, you're going to be slow. And especially when you start learning Swift and you're going to start learning the syntax, you're going to try to memorize keywords and you're going to try to memorize things, but you don't really need to do that. All you need to do is just build more apps, go through more demos, go through more tutorials, and your fingers almost, they have a mind of their own. So your mind thinks, you know, I want to open up that object library, and your fingers, they just kind of like know what to do, right? You don't have to think, oh, I need to press Command, Shift, and L. Initially, it will be like that, but as you do it more, it's just going to be very instinctive. So I just want to point that out. Don't get discouraged if it doesn't come easy in the beginning. Now I added this right here, and you'll notice that there's a yellow error now. It's not red like before. Red meant error. Yellow instead means this element doesn't have any auto layout constraints. So why don't we position this? Also, we're going to position it horizontally in container, and we're going to specify the bottom margin this time. And we're going to say that it's going to be relative to the first button by 20 points, right? Actually, I want to show you one cool thing. It's going to save you a lot of time, hopefully. So let's say that when I dragged my label, it was over here. It was like almost on top of that first button. And you know, I want to position it relative to that first button by 10. So I go ahead and enable that constraint. I hit 10, pull down this drop down, but the first button isn't there. I can't choose the first button in this drop down. Why is that? Well, the reason is because your label is overlapping that first button. So it doesn't come up as a neighbor here. So you need to make sure, if you want to make, you know, an element relative to another element, you have to make sure that they're not overlapping. And sometimes they could still be overlapping even though they don't look like that in the view, because we mentioned the frame earlier in this lesson. If you check this button out, you can see that the frame actually extends beyond just the word button. You can see these white dots here. So that's part of the frame. So even if the frame of the label is kind of touching the frame of the button, and you know, it's not like the text isn't overlapping, but at this point they could still be overlapping. In fact, yeah, they are. Okay, so I wouldn't be able to see that first button, but if I just drag it out a little bit more, I can then choose the first button. So hopefully that saves you a lot of time, because you might not realize that in the beginning. So let's add that one constraint. Boom, it's right there. Another cool thing is that, let's say I drag this away. You can see these lines, they kind of turn orange right now. And that's basically saying that the auto layout constraints for that label, they aren't taking effect right now because you like dragged it away. So what you're seeing on the view is not reflective of the constraints that you've added. To fix that, all you have to do is click this little update frames button. That's going to just run all the auto layout constraint rules, and that's gonna put everything where they're supposed to be according to the constraints that you have added. All right, so this label, we wanted this to say login or create an account. That's kind of what I wanted it to say, at least. Okay, we're gonna add another label. I'm gonna drag it like that. We're gonna put it in the center, and we're gonna position this guy, bottom constraint, relative to this label right here, and I'm gonna say something like 30. And this is just me making up stuff right now. So I'm gonna call this social squid. And in order to put this in 2 lines, what you can do is actually change the number of lines from 1, change it to 0, and that actually means multiple lines. Now inside here in this label, you can actually do line break. If you just press Control Enter, then you're gonna be able to put a line break. And we're gonna center this, and we're just gonna change the font. Now you might not have Avenir Next, and that's completely fine. Next, let's add some text to these buttons. So this one is going to be sign in with Facebook, sign in with Google, sign in with email. Now I want you to notice that you can add an image to these buttons, and that is going to add a little icon beside the button, or you could also add a background image, which is what we're going to be using. And you can set background colors and stuff, so you can really go in depth with customizing your buttons. But because this is an auto layout lesson, I want to focus on auto layout constraints and that sort of stuff and not customizing buttons. So I've actually prepared some graphic assets just to get the look and the feel of the button that we want without going too deep off the deep end on customizing buttons. So what I want you to do is grab these images, and these images I've made available either in the link in the description below, or you can click on the upper right corner and you can download these resources so that you can follow along. So after you unzip the file and you grab these asset images, just drag them into here. And just a quick note, if you don't understand why there are like 3 sizes of each image, 1x is the original size, 2x is 2 times as large, and 3x is 3 times bigger. The reason is because there's different resolutions of the iOS screen. So all the Retina screens would use the 2x, and the Super Retina ones would use the 3x. That's why there are 3 different sizes, and the right size will be used depending on what screen the device the user is using. So like I said, these button graphics, I added this rectangular background solid color to it. You technically could have just customized that. And in fact, if it were like a production app, I wouldn't recommend exporting your graphics like that. But like I said, this is for the sake of, because we want to focus on auto layout. Sorry, I'm losing my words here. So what I want you to do is highlight the 3 buttons by holding Shift on your keyboard and clicking all 3, and then choose alignment left. And that's not going to do it. Oh, actually, no, that's fine. That's fine. All right, that did do it. It's just that they didn't align left because the width of the buttons are variable right now. So I want you to click on that first sign in with Facebook button and change the background to Facebook, right? And you can see it's going to balloon up. We're going to change that text color to white so you can actually see it. And you can actually adjust the text inside that button by going into the size inspector and just setting the content insight to something like 20, for example. So let's do the same thing for the Google button, but let's just change the background image first. And then in here, we'll change the content inset. And then we will change the font color to black. And so sign in with email, add the email image, and change the text color to black, and change the content inset to 20. And then we are going to add a background to this. So search for image view, and all I want you to do is just plop it anywhere. It's just going to cover something. And I want you to choose background, and then I want you to hit this add new constraints, and we are going to enable all 4 constraints, and we are going to change, we're going to unconstrain to margins. I'll explain to you what that means in a second, and we're going to change these all to 0. So By default, there are margins for text, for example, and because we want the image to go like edge to edge, ignoring all the margins, you know, to all four sides of the screen, we are going to uncheck constraint to margins. Another thing to note is that there is something called a safe area, and because, you know, with the new iPhone 10s, there's like a notch. So the safe area is just an area where nothing will get obscured no matter what device you're using. So if you want, like, let's say you're laying out text, then you definitely want to stay within the safe area. So how do you stay within the safe area? Well, by default, all the constraints you add will be relative to being in the safe area. If you don't want to be in the safe area, so for this image, we want it to go edge to edge. We don't want to go under the notch, like we don't want to leave any gaps to the left and the right of the notch. And so we want to go all the way to the top of the screen. We would pull this drop down and then we would say relative to the view. Okay, and notice that changes the number back to 72. So just click all of these drop downs here and choose view instead of safe area. So we want to choose view. Okay, and change these all back to 0. Okay, and now add 4 constraints, and that is going to stretch it all to all 4 sides. Now, if you accidentally made a mistake, that's not a problem. Just go into the size inspector for this background, and here are the 4 constraints you've just added. Double click any of them, and that's going to highlight the constraint. And then in here, you can pull down the drop down and you can say, you can choose super view instead of safe area. So that's how you would fix it. Or you can just delete the constraint and re-add them. Now, the problem here is that our image view is covering everything, and that brings me to another important point, which is layer order. Now, if you look at this document outline, this is also called a view hierarchy. And the reason it's a hierarchy is because some of these elements, they allow you to put other elements inside of them, like they're a container element. Just like this view is. This view, this what represents our screen here, contains all of these buttons, the labels, and this background image. Well, you can have other container views, and you can have like multiple layers, so it becomes a hierarchy. And anything that is closer to the bottom of that hierarchy in the same level is closer to the user. So for example, this background image, right? It's all the way at the bottom of this hierarchy at this level, and that's why it's the closest to the user, and it's covering everything else. We want this background to be at the back, right? We want everything else to be on top of this background. So all we need to do is click and drag this guy and reorganize it to the back. So now you can see we've just pushed it as the back element. You can ignore the safe area here. Actually, if you click this, you can see where the safe area is. But anyways, that background now is that backmost element. So all of these elements are above it. Now that we have our layout looking kind of like what we want, I want to quickly talk about conflicting constraints. So why don't we do that example that we did earlier by making this logo, adding a second constraint so that it is relative to this guy, but 10 points away from that guy. Keep in mind there's already a constraint that says it should be 30 points above this label. I'm going to add a second conflicting constraint to say that it should be 10 points. And instantly you can see that there's an error illustrating that there are 2 constraints. One says 30 and one says 10. And if you click down here, you can you click this little error icon here, you can see there's conflicting constraints. So what you can do, you can just delete one of them, right? So you can't actually delete it from here, but you can highlight one of them and just delete it. That's going to fix the problem. So also, when you run your app, and if there are conflicting constraints, it's going to tell you in the debug console in this area down here. Okay, so how do you check if your layout looks good on multiple devices? Well, there is this little option here. It says view as iPhone 8. You can actually click this guy open and change the device you're viewing it on. So let's say 10R. You can change the orientation. You can see that it is a little squished, although you can see everything. And there are certain things that we can fix up pretty easily, and some things where we're going to have to add constraints to fix a specific device. So in order to give you finer grained control of how your UI looks on different screen sizes and devices, there is something called size classes, and they're kind of like categories of devices. So because Apple has created so many different sizes of iPads and iPhones, while you can't configure them specifically for a device, you can configure your UI specifically for a size class or a category of devices. And Apple has organized all of their different iOS devices into different categories. So we're not going to get into size classes right now because this lesson's already running kind of long, but I do have a bonus video for you that we will go into size classes, and I'll tell you what they're all about and how you can set auto layout constraints for specific size classes but not other ones, so that you can change the look of your UI depending on whether or not you have more space or less space. So you can do that, but it's not a requirement right now. We don't really need to do that, but if that is something that you're interested in right now, you can go grab that bonus training. Now, auto layout is just one of those things that gets a lot easier the more you do it. So I've got 3 practice exercises for you to do, and also another bonus auto layout training video that you can watch. You can grab all of these resources right there. In the next video, I'm going to show you a specific UI element that's going to allow you to reduce the number of auto layout constraints you need to add. It's going to speed up your design and construction considerably. Hello, today I'm going to show you how to use an element called the stack view, which is going to save you a lot of time when it comes to building your user interface. Now, in the previous lesson, I showed you how to use auto layout constraints to lay out all of the elements in your user interface. However, using a stack view is going to dramatically reduce the number of constraints that you need to specify. If that sounds good, then stay tuned. Alright, so we're going to redo that social login page, except this time we're going to use stack views, and you'll see how easy they are to use. This time we're going to create a single view app. I'll take you through this process. I'm just going to call this the stack view exercise. And these settings are kind of the ones that we've been using throughout here, so I won't go through them again right now. But if you're a little confused about them, go ahead and check out lesson 1. Alright, so we've got a brand new single view application. We're going to jump right into the storyboard. And I want to show you what this stack view element is all about. So go ahead, open up the object library, either clicking this button here or hitting Command Shift and L. And let's take a look at, actually first, what the stack views are. So we have a horizontal stack view and a vertical stack view. And just as the name implies, the stack view is a container element that allows you to put elements inside of it, and it's going to arrange them in a stack, either vertically or horizontally. So you don't have to, if you already want to arrange elements, let's say vertically, one on top of each other, you don't need to specify a whole bunch of auto layout constraints to arrange them nicely and align them together and all of that stuff. You can just use a vertical stack view, throw all of those elements inside, configure the stack view a little bit, and the stack view will handle everything else. So let's take a look at that. I'm going to drag a vertical stack view right there, and you can't really see it aside from this outline. In fact, if you click out of it, it's invisible because, like I said, it's a container element. So it by itself is not really a visible element. However, you will see it here in the document outline. And this is a very important point because since it's invisible on the screen, as you're adding labels or buttons or things into your stack view, it's kind of hard to drag them into the stack view when you can't see it in the view, right? And so usually if I'm adding elements into the stack view, I'll drag it directly into the document outline. So let me show you what that looks like. We're going to go grab a button, and we're going to just drag it directly into the stack view. And as you can see, with a little movement of my mouse, that little blue line either indents into the stack view, or if I move it out a little, it will become an element that is at the same level as the stack view. And if this is the case, then this button is not inside the stack view. It's in fact on top of the stack view. So in order to make sure that this button is inside the stack view, you need to just drag it and make sure that it looks like this, so that you can collapse and expand the stack view and you can see the button element inside of it. Let's add another element just so we can see some stacking going on, like that. So I've got 2 buttons. I'm just going to add a third one right here. So now the stack view has 3 buttons. And you can see I didn't put any auto layout constraints on these buttons. All I did was add them into our vertical stack view, and it's stacked them one on top of each other very nicely. Now, some of the properties that you can configure, just to go over them quickly with your stack view, is you can change the axis. So changing them to horizontal puts them side by side, and changing them vertical just puts them one on top of each other. Now, this means that when you're adding your stack view and you're choosing it from the object library, it really doesn't matter whether you choose horizontal or vertical, because they're both configurable to be either one. And so, you know, this vertical stack view here, all you need to do is change the axis if you want it horizontal. Now here are a couple of more fine-grained controls for how to position your elements inside. For example, I can just say spacing of 10 points. That's going to put 10 points in between each element. I can say 20, as you can see. It's just going to do that really simple, really easily. Now, if our stack view was a little bit wider, for example, if we stretched out the stack view to the edges of the screen, then I can show you what these are. In fact, why don't we do that? So we're going to grab our stack view here, and we're going to vertically align it in the container, and then we are going to stretch out the stack view 0, 0 on the left and the right. So if I click on the stack view, you're going to see that, well, that's the button right there. But this stack view, yeah, I can't really see the frame here, but I've stretched it out 0, 0 to the side. And you can tell because if you click on a button, you see that button width, it's all the way from the left to the right edges. So the reason why this button is stretched out all the way to the left and right sides is because of the alignment property that by default in the stack view is set to fill. So let's talk a little bit about alignment and distribution inside stack views. These two properties do take a little bit to wrap your head around because what they mean changes depending on whether you're looking at a vertical stack view or a horizontal stack view. So let's talk about distribution first. In terms of this vertical stack view, we've got this much space. You can see the white segment here, and we've got 3 elements inside stacked one on top of each other. Well, distribution is basically means how do you want to distribute the space to these 3 elements, right? In terms of how they are stacked vertically. On one hand, we could give each of these elements an equal amount of vertical space. On the other hand, you know, in the case that each of these buttons is a different size, like let's say they're a different height, we could use fill, which means that you're going to give the first element whatever amount of space it needs, and then you're going to give the second element whatever amount of space it needs, and then the third and fourth and so on and so forth. So each element kind of gets the amount of space that they need. In our case, all 3 buttons are uniform, so whether we choose fill or to fill equally, it looks the same. Fill proportionally, equal spacing, and equal centering are also other options. They're just different ways of distributing the space, and it's kind of hard to explain, so I recommend that when you do the exercise for this lesson, just play around with these options, take a look at what's different about them. But the best way, I think, to think about distribution is how do you want to distribute the space for the elements inside your stack view. Now, in terms of alignment, I always think of that like a word processor. So let's say you're writing a word and you're writing a paragraph, and you can either left justify it, you can center it, or you can right justify it. Well, alignment is the same. So right here, by default, it's set to fill, which is why it stretches out that button to fill up the entire space of the stack view. So that's what fill means. If you chose leading, center, or trailing, it wouldn't stretch out the element. Instead, it would either left justify it, center, or right justify it. So I can show you that. See, leading makes it go there. This is centering, and this is trailing. Okay, so let me set this back to fill. Now, the tricky part of this is when you set the axis to horizontal, then this meaning changes a little bit, right? So distribution on a horizontal stack view is still how do you want to divvy up that space for each of the elements. In this case, fill looks a little differently. You can see it still means that it's going to give the first element all the space it needs, second element all the space it needs, and then whatever space is remaining for the third element. Now, if I chose fill equally, it's going to give an equal amount of space, horizontal space that is, to each of those elements. And alignment now becomes, do you want to fill up the vertical space for each of these buttons, or do you want to top align it, center align it, or bottom align it? So when you're using stack views, you have alignment and distribution that you can play around with to basically get it looking the way that you want. So now what I'm going to do is try to recreate that social login screen. I'll show you how to do it without having to specify so many auto layout constraints like we did in the previous lesson. We're going to use a stack view to make it a lot easier. So let me first remove the constraints that we added to the stack view. So we're going to delete those 3 constraints, and we still have 3 buttons inside the stack view. And what we're going to do is we're going to add the image assets, and you can download these in the link in the description. So these are the same assets we used in lesson 2. So let's use these buttons and let's set the background image for them. So this one was Google and this one was email. And this said sign in with Facebook, and the text was white. So in order to align these buttons one on top of each other, I just have to change the spacing to 10, which is what we had in the previous lesson. And to align all of them together, well, all I need to do is just, I can center this stack view on the screen just like that. So all I've added are 2 auto layout constraints to the stack view. But other than that, the stack view is taking care of all of the arrangement of these buttons inside. And so I think what we also had was a label here. And yeah, so this label is going to give this equal space here. I might not necessarily want that. Choose a sign in method below. I forgot the exact wording that we used, but that's okay. So if I didn't want to give so much space, vertical space to this label, then maybe instead we can try using fill, right? Instead of fill equally. So you can see clearly the difference in that distribution setting right there. Now, as for the logo, because I want the logo to have a lot more space between the label, this label here, and the logo above, I don't want to necessarily place the logo into the stack view, because in this stack view, I can just choose a blanket spacing, and that's going to give a spacing of 10 everywhere. So instead, what I'm going to choose to do is I'm going to put the label above the stack view right there. Oops, let's undo that. Let me drag this label up here. So I want to put this, what did I call this? Social squid. Change the number of lines to 0. Right, and I'll center align this and just change the, I'll change the font to custom. And change it to like a bold type of font. And this one, I will just horizontally align it, and I will make it like maybe 40 from there. So it's gonna look like that. Because I want there to be a spacing of 40 instead of 10, that's why I don't want to put this label inside of the stack view, because otherwise, you know, I wouldn't be able to have this bigger spacing here. And lastly, we need to add the image view. And you notice that I'm dragging things into the document outline now, and sometimes that's just a lot easier to do. So I'm going to set the background image view to the background image asset that we have, and I am going to uncheck constraint margins, and I'm going to choose view. I explained why we do this in the previous lesson. It's because we want it edge to edge regardless of margins or anything like that. And then let me set all of these to 0. Let me add the 4 constraints. So we have this image now. And furthermore, because it's stretched like this, I'm going to change the content mode to aspect fill. And that is going to maintain the aspect ratio of the image while filling up the entire image view. And so we've got something like this. So now that you know how to use stack views and auto layout constraints, we're ready to build the UI of our next app, the War Card game. As always, I have recap notes and an exercise for you. Just download it right there below. Hello and welcome to lesson 4. Equipped with your new skills in auto layout and stack views, it's time to put them to the test. By the end of this video, you'll have built the user interface for your War card game app. So let's get to it. So we're going to start with a brand new Xcode project. Just click on create new Xcode project right here, or you can go into the file menu and choose new project. Now make sure you're looking at iOS and choose single view application. Here we're going to put the name of our app, and this isn't the public facing name, but it's just something that is going to give you a unique identifier combined with your organization name, and your organization identifier is going to create this bundle ID. And I talked about this back in lesson 1 and how it's going to be really important for an app that you're going to publish in the App Store. Now for this app, make sure you choose Swift as the language. You can leave these unchecked. And when you save it, you can also leave this unchecked as well for now. So let's create our project on the desktop. The first thing we're going to do is to jump into the asset library for our project. And I want you to go and grab the image assets now. You can do so in the link in the description below, or just check the card. It's just going to pop up in the right-hand corner. When you unzip the file, you can grab all of these images. You'll notice how each image asset has 3 different sizes. The first 1x, and then 2x and 3x. And this is what we talked about back in our auto layout lesson. It's for the different devices having different screen pixel densities. So we're going to just select all of them and then drag them into right here. Xcode is going to be smart enough to group all of them in asset names like this. These names, just pay special attention to them. Capitals matter, and you can rename them. These are the asset names which you are going to refer to these image assets when you want to display them. So I just changed the capital B to a lowercase b here to be consistent. And yours might already be changed actually. So I'll change that later. So when you download it, it should already be lowercase b. The next thing we're going to do is jump into the storyboard, and we're going to start by adding that green background. So go ahead and open up your object library. You can either click this button up here, and just in case you forgot, or press Command Shift and L. So let's go ahead and search for an image view. and drag it onto the view. And this is what we're going to do to display images. Now go ahead and click into this inspector, attributes inspector, and from the image property, let's choose background. Now we're going to stretch this out to all of the edges of the screen. Make sure you have that background highlighted and then click this add new constraints button. And we're going to want to uncheck constraint to margins because we want it to reach to the edges of the screen, ignoring margins. So leave that unchecked, or actually actively uncheck that because by default it is on. The other thing you want to do is pull down all these little drop downs and choose view instead of the safe area because we want to specify a margin that is relative to the view rather than the safe area. And just in case we didn't go through what the safe area is, if you go into the document outline right here and you click on the safe area, it's just that blue highlighted area is the safe area, and it's a place that's guaranteed to not be obscured by anything. So for example, the iPhone 10, 10R, 10S, and those ones, they have a notch at the top, right? And so the safe area is actually below the notch. So anything that you put in the safe area is guaranteed not to be blocked by elements like that. And especially if you can flip the orientation so that notch could be at the bottom or it could be, on any of the sides, the safe area will guarantee that it won't get obscured by that notch. Anyways, going back to our background image, make sure you have it highlighted again. Click on this menu. We're gonna have to start over. So uncheck constraint to margins and then choose view for all of these guys. Before you change the numbers in here, I would pull out down this drop down and change it to view first. And then go back and edit all the numbers to 0, making sure that all of these red margins are enabled. It's gonna say add 4 constraints down here. The reason why I want to toggle this to view first before changing the value here is because when you choose a new option in this drop down, it automatically changes that number in the text box. So, if you did it the other way around, you would have to basically change the numbers again. So that was just to demonstrate. Let me just double check that all of them are still set to view. Okay, so let's set these to 0, add 4 constraints, and you should see your background stretch to all 4 edges. Now, if you somehow your background isn't looking like mine, then you can always just open up this constraints. You can delete all of them and you can try again. No big deal. Next thing we're going to do is add another image view. So again, open your object library, drag an image view onto the view. This time we're going to choose logo. And ignore the fact that it's big and fuzzy or whatever right now. We're going to add some constraints to it first. So let's horizontally center that in the container. It's going to look squished. That's okay for now. And we are going to add a top margin. And we are going to leave it relative to the safe area. And we're going to leave constraint to margins enabled because we don't want this logo to be obscured. So we want to just make sure it's in the safe area. When you add that, the image view is going to use the intrinsic size of the image, which is just the size of your graphic asset. And so it's going to look like that. The next thing we want to do is we want to add a stack view. So you learned about these in the previous lesson. We're going to choose a horizontal stack view, and this horizontal stack view is just going to contain the 2 card elements. So go ahead, open up the object library again and choose image view. Now, we're going to put this in our view, but we can either drag it into the stack view on the view, or we can drag it into the document outline. And because the stack view is invisible like this, I usually find it easier to put it into the document outline. So that's what I'm going to do here. I'm going to drag it here. I'm just going to show you what a potential mistake is. Now, if you drag the image view and you try and put it inside your stack view and it's at the same kind of hierarchy level right here as the stack view, that's not what you want. You want the image view to be inside the stack view. So let me show you what that looks like. Let me move this image and let me just drag it into the stack view. Now you can see this little collapsible triangle appear beside the stack view. That means I can close it and open it. And when I close it, the image view is inside the stack view. So that's what you actually want. We're going to add a second image view into the stack view, so we have 2. And then you're going to click on the first image view and you're going to choose a card. So let's just say card 6. And you're going to click on the second image view and you're going to choose, it doesn't really matter, let's choose 10. And now let's add some space in between the 2 cards. So we're going to go on the stack view here and we're going to choose spacing 30 just to give it some space. Now before we align the stack view onto the screen, I want to put this horizontal stack view into a vertical stack view along with a button. So we're going to add the button first. Let's drag this button down here. And let's configure this little button a bit. For the image property of the button, why don't we choose the deal button? And actually I want to make one little distinction here. You can choose background or you can choose image. There's a slight difference. So for the image property, it's going to put that image beside the button text. But if you choose background, that image is going to appear behind the button text. So that's what that distinction is. All right, so now we have our deal button and we have the 2 cards here. I'm going to put all of these elements into a vertical stack view. So I want you to go into the document outline, highlight your stack view, hold down Shift on your keyboard and click on your button as well, and that's going to highlight both of them. And I want you to come down here and choose Embed in Stack View. What that's going to do is immediately take those elements that you've highlighted and put them into a stack view. Now Xcode is going to be smart enough to take a look at how your elements are oriented, and it's going to see that our horizontal stack view is above our deal button. So it's automatically going to put these 2 things into a vertical stack view. Check this out. Stack view, boom, vertical stack view. You can see this in the document outline, right? The other thing it does is it tries to set some of the properties of the stack view based on how you laid out the elements. So for example here, it set the alignment to center, the distribution to fill, and the spacing to 46 because that was the amount of space we had between the horizontal stack view containing the cards and the deal button. Now I'm going to change that a little bit. I'm going to say I want it 30 instead of 46. And now let me rename this in the document outline, because as soon as you're going to have more and more elements and you're going to have a ton of stack views or a ton of image views, things can get confusing. So you might have noticed for these UI image views, when we've set the image property of it, it automatically changes the name of that image view in the document outline. So that's helpful. But for the stack views, they're all just going to say stack views. So for this one, I'm going to say cards. Yeah, you can name it anything you want. Let's say cards and button stack view. Right, and for this one, maybe cards stack view. Okay, and for the button, you can name these 2. Right, so now let's collapse this and let's position this stack view onto the screen. So make sure it's highlighted. We're going to choose horizontally, center and container, as well as vertically. And that's going to effectively center the whole thing onto the screen. Now I'm going to make a slight adjustment here. I am going to go into the size inspector while I have this stack view highlighted, and I'm going to take a look at the 2 constraints we added. I'm going to double click the center Y constraint, and this constraint is basically putting it in the center of the screen on the Y-axis. I want to move that whole stack view down a little bit because I want to make sure that when you're holding your phone, your thumb can reach high enough to hit that deal button. So I'm actually going to change this constant, and I'm going to add 20 points to it to bump it down just a little bit. So just as review, I want to tell you this center alignment constraint is basically saying that the center Y of that stack view should equal the center Y of the entire view plus 20 points. That's what the constant is there for. That's why it gets bumped down a little bit. All right, so the next thing we want to add are the score labels. So why don't we open up our object library again and choose vertical stack view. I am going to just put that there in the corner, and then I'm going to add a couple of labels. I'm going to drag them directly into the document outline into that stack view. I'm going to drag 2 of them. So make sure that when you close the stack view, the labels tuck inside the stack view. All right, and now let me edit some properties of this first label and make the color white, and I am going to change the text to player. And for the second label, I am going to change it to 0. I'm going to change the color to white. I'm going to click this guy right here and change the font size to 40. Now I'm going to highlight the stack view because we want to position this in the lower left-hand corner. I'm going to choose this one, the margins, and we're going to make sure that constraint to margins is on and that it's relative to the safe area. It should be by default, right? And we're going to set the left one to 20 and the bottom one to 20, and this button should say add 2 constraints, and that's just going to position it there. There's one more thing I want to do, and that is to change the alignment to leading. So that's going to make sure that those elements inside that stack view are left aligned. Let's change the name of this, player score stack view. Now we're going to do the same thing for the CPU score on the right hand side, but this time I'm going to add the labels first, just to show you again the 2 different ways of adding stack views. So I'm going to drag 2 labels here, and check this out. You can do this. You can select both of them. Remember, you hold down Shift in order to select, click and select both of them, and I can change the properties for both of them at once. However, at this point, if I change the text, it's going to change it for both of them. So let me unselect them and just select the first one, and I'll change this to CPU. I'll select the second one and change this to 0. And then I'm going to change the font size as well to 40. And now I'm going to select both of them again by holding down Shift. And then I'm going to click Embed In and choose Stack View. Now remember, when you do this, it automatically determines which type of stack view is the best, horizontal or vertical. And obviously, because the elements were on top of each other, it chose vertical. But it also sets some properties for us which we might not want. So make sure you highlight that stack view. Let's go here. See, spacing it's set 3. So I actually want that to be 0, just like the other player stack view. In alignment, I actually want it trailing so that it's on the right hand side. Now let's put some margins on this stack view. So make sure you have it highlighted. Click on this guy. Make sure constraint to margins it's on. By default, it should be relative to the safe area, which it is. Let's change 20 and 20, and then down here it should say add 2 constraints, and there you have it. So you have something like this. Now I want to test this user interface to make sure that it looks decent on all screen sizes and orientations. So the way you can do that inside Xcode is down here. It says view as iPhone 8, and so far we've been designing this as iPhone 8 in portrait, but if you click this open, it's got a little tray, and yours might actually show the devices if you've got enough space on your Xcode interface. If not, you're going to get this sort of drop-down menu like I do. So let's first flip this into portrait. Actually, before we do that, make sure you press Command S and save, because Xcode sometimes can crash. You know, that's not out of the realm of possibility. So change orientation. Let's change it to landscape and take a look. So what did I tell you? An internal error has occurred. Editing functionality may be limited. This is not a problem. All we need to do is you can come up to product, you can clean build folder, and this is good learning for you in case this happens for you. And then you can just go ahead and quit Xcode, press Alt Q, and you can quit the whole thing, and then you can relaunch Xcode, and then just reopen your project. And that will oftentimes fix things. So you can see Here's my document outline. You can expand that. And here is my user interface. Now sometimes if yours has all these blue squares with question marks on them, all you need to do is just go ahead and change the device or change the orientation to force Xcode to kind of refresh things. All right, so going back to it, we have iPhone 8 in landscape. It looks pretty good, right? No problem there. And in fact, if we go up in size, you're just going to get more space. My biggest concern right now is just to make sure that no element is obscured or hidden or blocked or clipped or anything like that, and that the user interface doesn't appear broken. It's okay if you have extra space. You know, you can in the future take advantage of that extra space somehow, but what you really want to avoid is to have your elements kind of like overlapping each other in the case that there isn't enough space. So instead of going up, I'm just going to check the sizes going down, because I know as it's going to get to the smaller phone sizes, things may get clipped. So why don't we try portrait first? Let's just jump right down to the smallest screen size. So still looks good, right? Let's flip it into landscape, and there immediately you see that our logo is hidden behind the cards. It's probably not what you want, even if you think it looks okay. I mean, you can leave it. In my opinion, I would want to change that, and I'm going to show you how to change that. Let's go up one size just to see if the problem still exists, and it does. So let's go up one more, iPhone 8, and that one is okay. So we need to somehow address the situation for these smaller screen sizes. Now before we can do that, I need to tell you about something called size classes. Size classes are basically categories of screen sizes. Because there are so many different devices and two orientations for each device, that Apple decided to separate all of these into different categories of screen sizes. So when you're adding a constraint, you're able to say something like, add this constraint for all screen sizes, as in all categories of screen sizes, or only add this constraint for a specific size class. So this gives us some flexibility to change the layout depending on a specific size class. So let's say your app might look different on the iPad size class versus like a smaller device like an iPhone. And each size class is actually defined by two parameters, a height and a width. Now the height can be compact or regular, and the width can also be compact or regular. So for instance, one size class might be compact width and compact height. Another size class might be compact width but regular height. And in the case where you don't care about size classes and you want to add your constraint for all of them, it would just be any width and any height. Now let's dive back into our Xcode project, and I can show you how we can add a constraint for a specific size class. Now the first thing I want to draw your attention to is down here beside the View as iPhone SE. You can see what size class this device falls under. So this is the compact width and compact height. The first step of this is just to identify which size classes you have to fix. So we identified that iPhone 4S also has this problem, and the size class is also compact width and compact height. If we go up to iPhone 8, the problem doesn't exist, but this device still falls under the same size class. iPhone 8 Plus, this one's a different size class because it's regular width and compact height. So what we're going to do in order to fix this overlapping problem is add some specific constraints or variations of constraints to this specific size class, so that if the user is using a device, the iPhone SE or the iPhone 4S in the landscape orientation, these specific constraints that we add are going to take effect and they're going to correct that layout for them. So let me show you how to add constraints to a specific size class. So with the size class that you want to add your constraints into, choose Vary for Traits, and then we want to introduce variations, and that's just the specific constraints that I was talking about. We want to vary them based on both the width and the height. And that's going to target this specific compact width and compact height size class. Now this section turns blue and it tells you which devices fall under this size class. And you can see that it's the iPhone XS in landscape, the iPhone 8 in landscape, the iPhone SE in landscape, and the iPhone 4S in landscape. So any specific constraints you add right now to this size class is going to affect all of these devices in this orientation. So just keep that in mind. Now let's take a look at what sort of constraints we can add in order to correct this layout. Let's click on the cards and buttons stack view. So the first thing I think that we can do is just to shorten up the space between the button and the two cards. So you can see here that by default we have a spacing of 30, but we can click this little plus icon and add a variation based on a specific size class. So based on the compact width and compact height size class, let's add a variation. So you can see the WC and the HC, that stands for the compact width and compact height. And we're gonna say when we have this size class, instead of 30, I wanna do 20. Right, so that's gonna fix the problem a little bit, but I'm going to add a couple more variations to completely solve the problem. I think the next thing we wanna do is take a look at this logo, and we want to make it a little smaller for these size classes because the logo isn't a functional part, so I think I'm okay with making it a little smaller. Now we don't have any sort of height or width constraints for this logo, but what we can do is add a height constraint for the logo right now that will only take effect for this compact width and compact height size class. And so we're gonna, with the image highlighted, we're going to open up this add constraints button and we're gonna add a height constraint. And you can see right now it has a height of 67. I'm gonna change that to, or add a height constraint of 55. And when I add a new constraint now, it's going to be only specifically for this size class right here because this part is blue. If this part wasn't blue and it was just gray, then any constraints I add, just like we were doing earlier in this lesson, applies to any width and any height. So it's like all the size classes. All right, so let me add this height constraint of 55 to the logo, and it's only gonna apply for this size class. Boom. All right, so this logo looks a little squashed now, but we're gonna address that in a second. The first thing I wanna do is just show you the constraint we added and how you can tell that it's only applying to a specific size class. So let's click on this height 55 constraint, look on the right hand side, and you can see installed. This means it's only applies to the compact width and compact height size class. And up here it says there is nothing here. This is really the any width and any height size class. So this is unchecked. It's basically telling you that in normal circumstances, this constraint is not installed. It doesn't exist. But on this specific size class, it does take effect. It is installed. So that's how you can tell. All right, so now we're going to address the situation or the problem that this logo is kind of squashed. And if you click on it, it all goes back down to the content mode. And this would be a great chance for me to show you the different content modes. So let me first change the background temporarily to blue so you can see kind of where the boundaries of that image view are. So by default, set the scale to fill. As you can see, it pulls the image until it fills up that entire image view, right? Let's check out aspect fill. Now aspect fill will maintain the aspect ratio so it doesn't stretch the image. However, it's going to start enlarging that image until that image view is completely filled. And what that means is that some parts of your image might exist outside of the boundaries of the image view. Now that might be okay for you and it might not be. It really depends on what sort of layout you have. Another option you can have if you don't want things that are falling out of your image view, you can enable clip to bounds. And you can see when I click on that, parts of the logo just get clipped off, right? Where the boundaries of the image view are. And so that's what clip to bounds means. But really, the setting that I do want here instead is aspect fit. Right, so this is going to maintain the aspect ratio, but it's only going to stretch the image to the point where it fills the image view but doesn't exceed its bounds. So that I think this is a good way to see the differences between those content modes. So I'm going to choose aspect fit. I'm going to choose clear color as the background again. All right, so here it's starting to look a little better. You know, things aren't overlapping. But if you take a look at the bigger screen sizes, let's say this one right here, or the 10S, there's another thing that I want to do. I want to bump this down a little bit. So I'm just going to go back to the smaller screen sizes first, just to make sure that, oh, Xcode might be. All right, so I've got that internal error thing again, but it's just something we're going to have to deal with. All right, so I'm still varying for traits. I'm still going to move on. I think this is fine. Now, I'm going to select my cards and button stack view. I'm going to go into the size inspector. And remember we added this vertical centering constraint. And we added a constant of 20 to bump it down a little bit. Well, with this size class, I'm going to add a variation. I'm going to click this little plus icon. For compact width and compact height size classes, I'm going to add a variation, and we're going to bump it down even more. Boom. So to me, that looks a little more centered. So for these size classes, it's going to do 30 below the center, and for other ones, it's going to do 20. And then just double check that it looks okay on the other ones. So we've got the 4S, SE, the 8, and the 10. So I'm going to click Done Varying. And everything's going to look good now. So you can choose 8. You can just double check. Let's take a look at the 4S, the SE. It still looks good on the smaller screen sizes. And when we go into this specific size class, compact width and compact height, our size class specific constraints and variations are jumping in to save the day. Now, if you're having trouble putting this layout together, make sure you grab my Xcode project below and compare it with yours. See if you can find any differences. And if you're still stuck, just leave us a comment and we'll jump right in to help you. Now, in the next lesson, we're going to dive right into Swift programming. Hi, and welcome to lesson 5. In this lesson and the next two, you're going to be learning the basics of the Swift programming language. This is the stuff that you're going to need to know in order to complete the Work Hard game app, as well as our future apps that we're building together. Now, I know that this coding part can seem intimidating at first, but I really want you to stick with this. Really pay attention, and I highly recommend that you open up Xcode on your own computer and type out exactly what I'm showing you on the screen. By doing that, it's really going to reinforce the language structure and the keywords that I'm showing you. There's really no need to memorize anything at all. And I guarantee you by the end of lesson 10, you'll be writing your own Swift code. So let's get started. So go ahead and start Xcode, but we're not going to create a brand new Xcode project. Instead, we're going to create a playground. So click Get Started with a Playground, or you can go to File, New, and choose New Playground as well. Now you're going to get a screen like this. Go ahead under iOS, choose blank, and we're going to save this. I'm just going to save it on my desktop. Now first, let me tell you about what a playground is. It's not a full-fledged Xcode app project. Instead, it's just a lightweight file where we can try and test out some things. And this is perfect for us because we are going to just be running and testing some Swift code. Now let me give you a quick tour of the playground and the bare essentials that you need. So this big part right here where you're writing the code, that's the code editor. That's where we're going to be testing out all our code. Across the top, we have the status bar. Now mine says ready. It's ready to run and test some code. For you, it might be spinning and it might be doing something in the background, but when it finally says ready, then you're able to run your code. Now on the right hand side right here, we don't see anything. What I want you to do is just move your cursor to this line of code, line 3. Oh, that's actually one thing I want to mention first. If you don't have line numbers, go to Xcode Preferences, go to Text Editing, and enable line numbers. So that's one of the common questions that I get. I don't know if in this version of Xcode they've turned it on by default, but if they haven't, now you know. So yeah, move your cursor down to line 3, and you see lines 1, 2, and 3 highlighted in blue with this big blue play icon. Go ahead and click that. What that's going to do is basically run the lines of code up to that point where you click that button. So it's going to run the code lines 1, 2, and 3. You're going to get some sort of output here on this right hand side. This is the preview column, and yours might look a little different. So I don't want you to focus too much on the output on this preview pane. Depending on what version of Xcode you have, it could look different. Instead, what I want you to do is click in this upper right hand corner, hide or show debug area, or the console area. And in this lesson, we're going to be writing Swift code to output things into the console area. So I want to focus on the output in the console area here at the bottom rather than the output on the right hand side here in the preview, because that could look different for you. All right, now let's take a look at the code in here. Before I explain to you what these import var keywords are, I want to talk about comments. Now, if you've programmed before in another programming language, then you'll know what these are. But if you're completely brand new to coding, then I think this is a very important part to start off with. So let me show you what a comment looks like. I'm going to hit enter to start a new line, and I'm going to add 2 forward slashes like that. And then I can type a note for myself. This is a comment. Now mine looks like this grayed out text right here. Depending on what sort of color scheme you have going on, this could be green, it could be another color. But that's not the important part. The important part is that anything after these 2 forward slashes, this is not going to be run as code. Instead, it's going to be treated like a note or a remark for yourself and you can write anything in your comment to remind yourself maybe why you wrote that piece of code or what that piece of code does. When you're working with a team of people, it's crucial that you leave comments in your code so that when your teammates see your code, they understand your reasoning behind it and they understand why you wrote it. Now, if you're working by yourself, it's also important to leave yourself comments, because if you leave your project and you come back months later, you won't remember why you wrote that code unless you leave yourself comments to remind yourself. All right, so let's talk about this first line of code where it says import UIKit. Now we're going to talk a lot more about UIKit in the future, but for now just understand that UIKit is a library of code that Apple provides for us to build apps with it. It contains useful elements like buttons and labels and templates of code that we can use to speed up our app development. Import is a special keyword to say that we want to use the UIKit library in this file. Now let's talk about line 4. This var str equals hello playground. In order to understand this, we need to first talk about variables. In an app, there's a lot of data being passed around, and you need a way to keep track of it. Well, that's what a variable is for. You can think of a variable as kind of like a sticky tab. You know those ones where you can write something on it and stick it to a piece of paper to keep track of it? Well, let's take a look at the line of code below, which is declaring a new Swift variable and assigning some data to it, and see how that compares to using a sticky tab and sticking it on a sheet of paper. So var is a special Swift keyword that is declaring a new variable. Using our analogy, you can think of this as creating a new sticky tab. str is the name of that Swift variable. In the case of our analogy, str is what you write on that sticky tab. Now, hello playground is the piece of data that we want our variable to keep track of. In our analogy, that would be the sheet of paper that we're intending to stick the sticky tab on. And finally, the equal sign is us actually assigning that piece of data to that variable. In our analogy, that would be like sticking the actual sticky tab on the piece of paper. Now let's go back to our playground and take a look at that line of code again. Now this line of code makes a lot of sense, right? We are declaring a new variable, str, and we are assigning the piece of data, hello playground, to that variable. Now let's consider another scenario. Using the same analogy of the sticky tab, what if we decide to peel off that sticky tab and stick it on another sheet of paper? Well, we can do the same thing with our variable, except that there's just one catch. Imagine that when you were writing the name on that sticky tab, str, you wrote it with a permanent marker. And so when you peel off that sticky tab and stick it on another sheet of paper, it's still saying str on that sheet of paper. Well, we can do the same thing with our variable here. We can take our variable str and we can assign another piece of data to it. So let's say another some data. Okay, and what you can do is use this blue icon here, and let's just run our code, and you should get some sort of preview there. Now notice that on line 6, I don't have to write var again, because var was just to create that variable in the first place. When I use it again, I can just refer to it by the name. And you might notice that sometimes I say create. That's just so that you can understand it a little easier. The proper terminology is declaring a variable. So now let's write some code to output some of this data into the console area below. On line 5 here, let's write the keyword print, and you might notice that Xcode pops up this little autocomplete menu, and that's just Xcode trying to guess what you're trying to type and presenting you a bunch of options to make your life easier. Now, while you can select some of these options, that's not what we're going to do right now. We're going to open up a round bracket and we are going to type str, and if you don't have a closing round bracket, you should just type it. What we're going to do now is just bring your cursor down here to line 7 or at the end of your code file and click run, and you should see hello playground down there below. Now notice that it doesn't say some data, and that's because we are printing out the contents of str at line 5 right after we assigned hello playground. So it's showing you the data that str is pointing to at that point. Now if we ran another print statement here, let's click run, you'll see this print out again, but this time it says some data, which is what we assigned to it on line 6. Now the next thing we're going to talk about are constants. Constants are like variables, except that once you assign some data to a constant, that's it. You're not going to be able to assign anything else to the constant. Now, using our analogy, that is like super gluing that tab to that sheet of paper. There's no way you're going to get that tab off. It's bookmarked to that sheet of paper, and that's the piece of paper it's going to reference forever. The syntax for declaring a new constant kind of looks like what we did with a variable, except that we used the let keyword instead of the var keyword. Now let's go back to our playground and we'll try it out. Now let's try declaring a constant at the bottom of our playground. Let's say let str equals more data, and give it a sec, or you might have to run your playground, but when you do, you're going to get an error, and it's basically saying that you cannot use str again because your variables and constants must have unique names. Even between two variables or between two constants, you have to have unique names. So why don't we change str to con? And it has to have unique names, just on a side note, because otherwise it would be very, very confusing. So we have con here, and let's try modifying that data for that constant. And give it a sec. And Xcode is going to tell you that you cannot assign another value to constant or con because let is a constant. So you can't actually do this, but with variables we can, right? This goes back to us saying that constants, once you assign a piece of data to it, that's it. So now you might be wondering, when would you use a constant versus a variable? Well, the general rule of thumb is that you should be using constants whenever you can, but however, if you're keeping track of a piece of data that you expect might change, then you would use a variable, because a constant is a lot safer, right? Once you assign a piece of data, you can be guaranteed that that's not going to change on you. So in fact, even inside of Xcode, when you're programming, if Xcode notices that you use a variable and you assign a piece of data to it and you never reassign anything else to it and it doesn't change, it's going to say, hey, why don't you change this into a constant? You're going to get that reminder. So the general rule of thumb again is to use constants, and if you realize that that piece of data needs to change, then you can change that constant to a variable by just changing that let keyword to a var keyword. All right, so let's erase this line here. Now, one other thing I want to point out, and you might have noticed this, is that all of the data that we've been assigning to our constants and variables thus far have just been this text data. Well, there are actually other types of data as well. And that brings us to our next topic, which is data types. The pieces of text that we've been assigning to our variables and constants are called strings. Now, I know that's kind of a strange name, but you can think of it as a string of characters, right? Well, they're just basically pieces of text. Next up, we have Boolean, or bool for short, and these represent true or false. Great for pieces of data that can only be one of two values. Now don't worry, we're going to try all of this out in the playground in just a second, but next up we have integers, or int for short. Just like back in math class, integers represent the whole numbers in the positive to the negative range, including 0. Now you might ask, where are our decimal numbers? Don't worry, I've got you covered. Float is what you're looking for, and these represent our floating point data. In other words, our decimals. I've just showed you 4 data types, but there are actually more, but these 4 are great to start with. I have a Swift cheat sheet at the end which are going to show you the rest, and also a worksheet for you to practice what we've learned in this lesson. Now let's go back to our playground and try this stuff out. Alright, so now let's try some of those data types that we just talked about. Let's type in var b equals true, and let's print b. Now let's try running this line of code here. You're going to see true appear down in the console below. Now true is a special keyword that you can use to specify a Boolean value. We can also change this to false. Let's run this again, and you can see false appears on the console. Now that we're running more code, I want to point your attention to a special feature of the playground, and down here in this stop playground button, you can actually hold it and choose automatically run. When you do that, your playground is automatically going to execute the code in your playground automatically as you're typing. So you never have to click on that run button again. The only problem is that sometimes playgrounds can be buggy. So if you're experiencing a lot of crashing or it's not running your code, then you're going to want to switch back to manually run, and you're going to want to click on that run code button manually. So we're going to leave it automatic for now and see how it goes. If we're experiencing problems with our playground, then we're going to set it to manually run instead. Alright, so now let's try out integers. Let's do var I equals 32. That is going to declare a new integer and assign it 32. We're going to assign it 0. That's also an integer. We're going to try assigning, let's say, -10. It's also an integer. Now let's try the last data type we talked about, which is float, and it's going to be some sort of decimal number like that. Now there's one important thing I want to talk to you about, and that is that there are actually 2 types of decimal numbers. So the first decimal number data type is float, like we talked about, but there's also something called double. That's another data type that represents decimals, and in fact, double is a lot more precise than float. That means that a double data type can store a lot more decimal points than a float data type can. And when you're working with the Swift programming language, double is actually the default data type. Now the thing is, it's important to know both float and double, because sometimes when you're working with third-party code libraries, or even some of the libraries inside UIKit, some of them expect float data types and some of them expect double data types. And so it's important to know both, and now you know. Now the next thing I want to talk to you about is the fact that variables and constants can only store one data type. Now what do I mean by that? I'm going to demonstrate. So here we've declared a variable called I, and we've assigned it an integer. And then we've reassigned it 0 and -10, which are also integers. But what if suddenly I decide to assign it some sort of decimal number, right? We know that decimal numbers that's not considered an integer. So in fact, right here, the playground is telling us, it's erroring out, and it's saying that you cannot assign a type of double to your integer variable. You just can't do that because the variable I only accepts integers. Now here's the thing, where did we say that variable I can only accept integer data types? Well, the funny thing is that we didn't explicitly say that. What happens is that when you declare a variable or constant and you assign a piece of data to it, that first piece of data it's going to take that data type and infer that that's the data type that variable can store, and that's the only thing it can store. So the very fact that we assigned 32 being an integer to variable I, from that point on, variable I can only store integer types. That is why we cannot assign this double data type value to I. Same thing goes for this up here. Because we assigned the Boolean value false to b, now the variable b can only store Boolean types. So I can assign true to it, but I cannot assign a piece of string to it. I cannot assign a number to b. And so we're going to get these errors right here. All right, so we've just experienced a crash on the playground. It's okay. Let's just go back to manually run. And we'll run our code right here. And that should be okay. All right, so we're back to being good. Now there is a way to explicitly say that a variable can store a certain data type. This is how we would do it. So after your variable name, you would write a colon, and then you would write in the data type that you want that variable to store. So you can write like that. You could do that. Up here, you could do that. And then for this one, you can either type float or use the Swift default double. So I would recommend using double when you can, unless you're using some sort of library that requires you to use some float data. So here's the funny thing. Even if this is the first piece of data you assign being float, simply because you declared your variable as an integer, you've explicitly said that variable I is an integer data type, you cannot assign a double data type to it. So those are the things that I wanted to point out to you. I know it's a lot to absorb. I would recommend getting the recap notes and just reviewing it, and also doing the exercises. It's going to help you solidify these things in your head. So far you've learned about variables and constants and how they can be used to store data. You've also learned about data types such as int, string, Boolean, and float. Now all of this is going to be in the Swift cheat sheet, which you can grab below, as well as the stuff for the next 2 Swift lessons. I also have a worksheet for you to try to practice using Swift variables and how to perform math operations on them. So make sure you try that and get some extra practice in. Hi and welcome to lesson 6. In the previous lesson, you learned how to write some basic Swift code. Well, let me ask you something. How does a user usually interact with an app? Well, it's usually they tap on something on the screen, let's say a news headline, and then the app gives a reaction, such as showing that news article. Action and reaction. Well, that implies that when the user takes an action, depending on what that action is, the app needs to react accordingly and run the appropriate block of code depending on what the user is doing. So we need a way to organize our code into bite-sized chunks so that when the user takes this action, we run that chunk of code. And when the user takes that action, we run that chunk of code. Well, Swift has something called a function, and this is basically a block of code where you wrap it up with a name, and when you want to run that block of code, you can just call it by its name. So let's open up a new Xcode playground and see how we can declare some functions. All right, so we're going to create a brand new playground here, and we're going to try out these functions. So let's get started with a playground. Under iOS, let's choose blank, and I'm just going to save it on my desktop and call it my playground 2. All right, so we're going to just go down here, create a new line, and we're going to type in func space. Now that keyword is used to declare a new function. The next part of the function is the name of the function. Now this is important because whenever we want to run the code that is inside this function, we're going to call it by this name that we're going to give it right now. So I'm going to call this function say hello. Now the next part of the function is a pair of rounded brackets. So find that on your keyboard. Typically it's right above the 9 and the 0. So you're going to have to hold down Shift and you're going to type those two rounded brackets. Now inside those rounded brackets, right now we're not going to put anything in there, but you can have something called parameters, which is something you're going to learn a little later in this lesson. All right, now next we're going to hit space and we're going to open up a pair of curly brackets, or squiggly brackets, some people call them, and you got to find these on your keyboard too. For my keyboard layout, it's above the square brackets. So I'm going to hold down Shift and type in a pair of squiggly brackets or curly brackets. Go inside it and press enter a couple of times to create a few lines. You're going to write your code for your function in between these two curly brackets. Think of it as the guts of the function. So whenever you call say hello, the code in between these curly brackets, it's going to get run. I'm going to print out in here hello. All right. Now let's go outside of the function. And by outside, I mean after this ending curly bracket, we're going to just call the function by its name, say hello. And notice that autocomplete already brings this up. But let's type it out just for extra practice. So we're going to use the name of the function followed by the curly brackets. All right, now let's run this line of code. You'll see down here, it's going to execute this print statement and it's going to print out hello. And if you don't have this tray at the bottom, you can open it up like that. When you write a function, you're usually writing some code to perform a specific task. In our example before, you wrote a function to display the full article. And when the user taps on a news headline in the app, you're going to call that function to display the full article for that headline. Now, let me present another scenario. What if there are 10 news headlines in your news app? Are you going to write 10 different functions, one to display the full article for each headline? Of course not. Furthermore, the news changes every day, so you wouldn't be able to write a function to show a news article that hasn't happened yet, right? Instead, you're writing a function to do the work to present and display a full article to the user. That function doesn't care or doesn't know about what sort of article it's going to be presenting and displaying. You as the coder basically pass that information into the function when you call that function. You can do this with something called function parameters. Remember those rounded brackets in the function call? Well, you can specify the parameters in between those rounded brackets that indicate what sort of data you're passing into the function when you're calling it. In the example below, we declared a function called sayHello2. In the rounded brackets, you have a parameter called name, and it's of the data type string. Now that kind of looks like a variable declaration without the var keyword. Whenever you call the sayHello2 function, you're going to have to supply a piece of string data into that function call. Now let's jump back into our playground and see this in action. All right, before we jump into an example with parameters, let's first add a comment up here and let's call this a basic function. Remember, this is something you should get into the habit of doing. And I also want to show you, if it wasn't clear, how to use the autocomplete feature, because trust me, you're going to be using it a lot. So why don't I type say hello? You're going to notice that it pops up right here. Now you can either hit enter right now, or you can press up and down on your keyboard to select a different one, and you can even use your mouse and you can scroll down the list. And so here I'm just going to double click it. All right, so now let's do a function with parameters. So again, we're going to type in func space for declaring a new function, and this time I'm going to call it sayHello2, and we're going to specify the rounded brackets just like before, except that this time I'm going to move my cursor inside the rounded brackets and we're going to put a single parameter in here. Let's call this parameter name colon. We're going to specify the data type. It's just like almost like declaring a variable like we did in the previous lesson. All right, so now we're going to open up a pair of curly brackets and we're going to add some space in there. And here we are going to print out the name that gets passed in. And the way you can do that is just by referencing that parameter name. So since we called it name, we can just say print name. So whatever data gets passed into this function when it gets called, we are going to be printing it out into the console. So right now, even if we run the code, it's not going to do anything. We actually have to call the function. So here, below the function, let's type in say, and you can see that now autocomplete shows you this second function that we just wrote. So go ahead and select that and press enter. And this highlighted blue part is telling you that you need to specify a piece of string data along with this function call. So why don't we go ahead and type in Tom there, and then let's run this line of code at this point. So you're going to see Tom there, right? And that's just a result of us passing this piece of data into the say hello to function. So that's going to come in through here, and then it's going to take that string data and print it out to the console. And that's why we get this result down here. Now, what if we wanted to say hello Tom instead? Well, we can do that. And I'm going to show you a really neat way to do that. So let's erase this name here, and instead let's print out a string called hello space. And we can actually insert that name parameter into the string. And the way you do that is backslash, and then type in a pair of rounded brackets. And inside the pair of rounded brackets, you would just put the name of your parameter or variable or whatever you want to insert into the string. Now let's run this function call again. Now you get hello Tom. Now in this example, we've done one parameter. You can actually include multiple parameters into your function. All you would have to do is inside the rounded bracket, after the first parameter, just type in comma, and now you can require a second parameter. So let's make this one age, and this data type for the age is going to be an integer. So immediately, the playground is going to complain that this function call is no longer valid, and it's right. It's missing an argument. It's missing this parameter called age. So what I'm going to do is just completely get rid of this line, and we're going to type in say, and you can see here that autocomplete has detected we've changed that function. So let's double click it or press enter, and we're going to fill in the parameters that are needed. Now here's a neat trick. As you're filling in the parameters here, if you press tab on your keyboard, it just automatically jumps to the next parameter that you need to fill in. So that's a shortcut that's going to help you. So let's type in something like 20 years old, and let's run this code. Now again, it just says hello Tom because we haven't included the age parameter in this print statement. So why don't we modify this piece of text? You are backslash rounded brackets. Let's insert that age, years old. And now let's run this function again. And now you're going to see down here, hello Tom, you're 20 years old. Now you can actually specify more parameters, but I wouldn't go too crazy with this. In the future, as you're going to get more advanced with Swift, you're going to learn ways to combine pieces of data together into one parameter, and so you don't have a long parameter list that you're going to require. But for now, if you wanted to include 2, 3, 4, 5 parameters just to play around, feel free to do so. It's going to be good practice. There's one thing that I want to mention, and that is that you can actually omit these parameter names right here. So it's going to I guess save you a little bit of typing. Sometimes it can be nice to have them so that it's really clear what sort of data you need to pass in. But let me show you how you could do a function call where you can omit this. All you would need to do is back in your function declaration here, you would just include an underscore space in front of that parameter. So we're going to do the same thing with the age here. And then we're going to get rid of this line. In fact, Xcode is now, or Playground is now telling you that you don't need these things. So let's get rid of this line and again use autocomplete, and you can see There's our function. Visually here, it doesn't look any different, but if you press enter, you can see that this whole thing is highlighted now. And when you add your parameters, right, it's just gonna look like that for your function call. So what you're actually doing here by adding this underscore is you're omitting something called the argument label. Now I'm not gonna get too much into it right now because I don't want to confuse you with a lot of knowledge that you don't need right now, but just know that that's something that you can do. I will link to some resources in the description if you want to read more into it, but if even if you don't, as you're going to get a little more advanced with Swift and you're going to learn more about functions, you will come across this knowledge anyways. So it's nothing that you need right at this moment. Now you know how to write functions which expect some sort of input data to work with. Another great use of functions is to take that input data, process it, and transform it, and then return it back to us. Now functions can do this using the return keyword. In the function below, it takes an integer input, it adds 4 to it, and then it returns the result back to us. Now notice that after the rounded brackets, there's an arrow followed by the data type int. Now this describes the type of data that the function will return when you call it. Now let's go back to our playground and we'll try this out. All right, so now let's try out a function with the return value. So why don't we just type in a new comment here with return value. And I'm going to create a new function by typing func space, and then I'm going to call this function add 4 to, and you guessed it, we're going to add a parameter in here. I'm going to call the parameter x, and it's going to be an int data type. And here is where we get to the return value part. So we're going to type in a dash, a greater than sign, space, and here we indicate the data type of the value that is going to get returned by this function. So since we are simply taking in an integer and we're going to add 4 to it, it makes sense that what we're returning out of this function is also an integer. So that's what we type in there. And then we are going to hit space and write in our curly brackets there. Now I'm going to open up the curly brackets a little bit so we can type some code in between them. And what we're going to do here is we're going to create a brand new variable here. Let's just call this sum. And sum is going to be equal to x, which is the value that gets passed in, that integer. And we're going to add 4 to it. Now, from here you can see that the playground is complaining that we're missing the return in a function that is expected to return an int data type. And it's right, because we need to return this sum. The keyword that we use is actually just return. So type in return space, and we are going to pass back the sum. So if you let Xcode run, or maybe you can run your code at this point, you're going to get rid of that error. So let's try this out. Let's try calling this function. add 4, and autocomplete brings it up. Let's hit enter. Here we're going to pass in, let's say 10. Let's go ahead and run this function at this point. We don't really see anything. I mean, you see the result in the preview here, but like I said, we're going to pay attention to the console. Nothing gets output here. Well, where did that 14 go, right? What's actually happening here is it's passing in 10 into this function, right, through this parameter. Then it's adding 4, and then it's returning the sum. And we are actually responsible for capturing that data. So in fact, what we have to do here is we have to type in var, let's say result equals the execution or the return result by executing this function. So if we print result and we run this code, we're going to see 14 down there in the console. So just to run it through one more time, what's happening here is we're executing this function, we're passing in 10 as a parameter, then this code inside this function gets run, right? It's going to take 10, which we passed in, it's going to add 4 to it, it's going to assign it to the variable sum, and then it's going to return the data, sum, right? And that's going to come back here, and that sum gets assigned to result, and we're printing the result. Now, one question you might be asking yourself now is, why do I have to use return values? Why do I have to use this return keyword here? Why can't I just access sum right here? Why can't I just say print sum? So why don't you go ahead and try that and run your code, and you're going to get an error that says use of unresolved identifier sum. And if you scroll up here, that's the same error message, but it's basically saying that it cannot find anything called sum. Well, what do you mean? We have sum declared right here inside this function. This brings me to my next topic, which is variable scope. You see, the code that is inside this function right here is inside of its own scope. So any variables you declare in here only exist within that function. And that's why in order to get that data out, you have to use the return keyword. What I find helps beginners to grasp this concept is by thinking of the code inside of the function as existing in its own little bubble. So anything that, the code that you write here, the variables that you declare inside that function is in its own little bubble. And in order to get that data out, you're going to use the return statement here. Now, another thing I might add is that each function has its own scope or its own bubble. So if I, let's say, declared another function, let's just call this C, and I try to print sum in here, I'm also going to get an error, right? Because sum exists in this function's scope. I can't access it anywhere else. Each function has its own variable scope. Now, I know this variable scope concept is a little bit abstract, but what's going to happen is that as you're writing more Swift code and you're building your apps, you're going to run into issues where you're trying to access this variable inside the scope, and then you realize that you can't, and it's just something over time that you're going to realize, and it's going to click if it hasn't already clicked for you. So I guess what I'm saying is that give it some time, and don't worry if it's kind of confusing to you right now. What I'm saying is that as you're writing more code and you're building more apps, you're writing more functions, these things are going to fall into place for you. So let's erase that test function, and let's address this thing. It's so annoying. This variable sum was never mutated. Consider changing to a let constant. So this goes back to what we talked about in the previous lesson. When should you use variables and when should you use constants? Well, I told you that you should default to using constants, and then if you find out that you need to change up that data and you get an error to say that you can't change it up, then you can consider changing that let to a var and using a variable instead. So here, Xcode is warning you that, hey, you declared sum as a variable, but in fact, after you've assigned some data to it, you never ended up changing it. So why not use a constant? And so Xcode is being very helpful, not annoying, in fact. Let's change that to a let, and we're all good. Now, before we jump to the next lesson, one last thing about autocomplete. So I want you to notice when we typed in add 4 to, this right here, this is the return value. So when you're looking through different functions to call, this is very handy to understand what sort of data this function returns. What happens if we try to now call one of these guys, say hello to, or say hello? In fact, these guys, they don't have return values, right? So what happens when we try to autocomplete that? Well, it says void. Well, void basically means no return value. So that's what it means. And why? Why does void say that? Because in fact, let's go back to the basic function here. In fact, right here, the return value is actually void. It's just that we don't have to type it when it's void. So you can actually specify a return value of void, which is basically no return value, and you don't need a return keyword. So that's just a neat little fact, right? When you don't need a return value, you don't need to specify this part of the function declaration. You can kind of omit it. But the interesting part is when you use autocomplete to call this function, it still says that the return value is void. Alright, so today you learned about how to organize code into functions. You've learned about input parameters, which let you supply functions with input data. You've also learned about return values, which let functions return data back to us. And finally, you've learned about variable scope, which is basically all of the variables and code inside of a function only exist within the scope of that function. Believe it or not, there's still a lot more to functions, but what we've covered so far is more than sufficient for now. I've got a worksheet for you to practice and solidify what you've learned, so make sure you grab that, and I highly recommend that you go through it. Hi, and welcome to Lesson 7. So far, you've learned some basic Swift code and how to organize that code into executable blocks called functions. Well, in this video, you're going to learn how to organize and group your functions into what's known as classes. Now, before we go on, I just want to say one thing, and that is that learning something new is hard. Seriously. I know firsthand because I failed at learning iOS programming when I first started. So give yourself a pat on the back for coming this far, especially if you've never coded before. Now I know you might be asking yourself, constants, variables, functions, why the heck do I need to know any of this? Well, I can guarantee you that after this lesson and into the next, all the pieces are going to start to fall into place for you because we're going to move back to our Xcode project and I'm going to point out all the different pieces that you've been learning about in the last 3 lessons and you're going to have a eureka moment. You're going to see that Xcode project in a different light. So I want you to pay extra careful attention in this lesson because it's the last one before we move back to our work hard game Xcode project. All right, let's do this. So on the screen, I've got 2 functions right now. They don't really do anything, but one is called cruise and one is called thrust. So let me explain why. Imagine yourself as an engineer for NASA and you're writing the code to power one of their rockets. Now, all of the code for cruising, you would put inside the cruise function, and all of the code that are going to turn on the rocket thrusters, you're going to put inside the thrust function. Now, just like how you organize that code into those functions, you can further organize these 2 functions into a class, because potentially you could have many functions, right? So a class, you can use it to group together functions that kind of serve the same purpose or the same goal. So let me show you how to declare a class first of all. Use the class keyword, and then you would give the class a name. So I'm going to call this rocket. No, I'm going to call it spaceship, just because I like that word a little more. Now you open up a pair of curly brackets, and I am going to put some space inside the curly brackets, and I'm going to highlight these 2 functions. I'm going to press Command X to cut them, and I'm going to press Command V in there to paste it. So what we have now is kind of like 3 levels of organization, right? At the top level, we have this spaceship class. Inside the spaceship class, we have 2 functions, cruise and thrust. And inside each of those functions, we have the code to essentially carry out those abilities. Now, there's one distinction I want to make, and that is that when you move the function into a class, those functions are now called a method of that class. So I know it's a little confusing because nothing's changed except what you call them, right? When there's a standalone thing, they're called functions, but when you put these functions inside a class, they are now called methods of that class. But it's sort of interchangeable. If you say, the cruise function of the spaceship class, people will still understand what you're saying, but I just want you to know that the correct terminology is that cruise is a method of spaceship. All right, just a little distinction there. Let's illustrate this in a diagram. First we had functions, and then we put them inside of a class, and now they're called methods. I want to talk about variable scope for a second. In the last lesson, you learned that declaring a variable inside of a function, it only exists within that function's scope. So for instance, if we declared a variable called name in function A, we can't access that name variable in function B because function B has its own scope. The same goes for the reverse. If we declare a variable in function B, we can't access it in function A because that variable would only exist in function B's scope. Now get this, the class itself has its own class scope. You can actually declare a variable inside the class but sits outside of any particular function. Now this variable exists inside the entire scope of this class. Since function A and function B are also inside the scope of this class, they can actually access that variable. Finally, here's the kicker. When you declare a variable inside the class, but it's outside of any functions, like what we've done here, it's actually called a property of that class. Now let's see this in action. So let's go ahead and declare a property of our spaceship here. Now it's going to be inside of the class, right? That's the starting curly bracket, but it's going to be outside of any of these two functions. So I'm going to put it up here. I'm going to call it a fuel level, and I'm going to assign 100 to it. Now this fuel level property is inside the scope of the class, just like how these two functions are also inside the scope of the class. So I can actually access the fuel level property from here. See, I can print it out. Now it's not going to actually print anything because we need to execute these functions, and we're going to do that a little later on. But just from the fact that, actually, let me run it just to show you that the playground isn't going to throw any sort of errors, right? So it can access this property. However, let me declare a variable in here. Let's just say var test is equal to true and make it a Boolean, right? This variable, because it's declared within the cruise function, it only exists inside the scope of that function, that little bubble. So I cannot access it from here. Let's say print test, and you're going to see that Xcode is going to throw an error. Let's run that. So it's saying that it cannot find test because it only exists within this scope. So now let's go ahead and erase this test code here. And like I said before, if this scope thing is a little bit confusing, it's going to come with time, I promise you that. As you're going to write more code, you're going to understand this stuff a lot more. There's going to come a point where these things suddenly just like click for you. All right, now we're going to take a giant leap, and I'll explain to you how classes are used. Now it's going to require a little bit of abstract thinking. I also want to add that in my 6 years of teaching iOS app development, this is the single hardest concept to understand for beginners who have never coded before. But once you understand this, then you will have crossed the biggest hump that so many people give up at. All right, I'm done talking. Let's do this. Now let's use the same analogies we used before. Suppose we have some data and we have variables and constants as sticky tabs. Now we have functions that encapsulate these pieces of code, and let's say that functions are like file folders. Now we have classes that contain a bunch of functions and variables, and let's say that class is a file box that contains file folders. Well, at the end of the day, what we have is just a file box full of instructions. It doesn't actually do anything. Some people say, let's think of the class like a recipe. Some people say, let's think of the class like a blueprint. What's the common thing here? They all need someone or something to turn this set of instructions into action. Someone to take those recipes and turn it into a cake, or someone to take the blueprints and build a rocket ship. Now this rocket will work exactly like it was designed to. It can thrust and it can cruise because we've given it functions to do so. But understand that class doesn't thrust or cruise. It's the actual object that gets created from the class that will thrust or cruise. Furthermore, once you have a blueprint, you can make multiple spaceships. Each of them will have its own fuel level and ability to thrust or cruise. The blueprint is called a class, and the objects that are created are called objects or instances of the spaceship class. All right, so who is the person that will take that class and turn it into an object? Well, that's the device in your hand. It's a mini computer. You write your instructions in Xcode. Xcode will turn it into a format that can be understood by your device, and your device carries out those instructions. So here's the tricky part. You need to write instructions to tell the computer to take your classes and to turn them into objects. And furthermore, you need to write instructions to tell the computer how you want it to use those objects. For example, you write instructions like, when the user taps the liftoff button, then you create an object from the spaceship class, then call the thrust function of that object, then call the cruise function of that object. That could be an app right there. Now let's go back to our playground and see how you can write instructions like this. All right, so you just learned that a class with its properties and methods they don't actually do anything until you bring it to life by turning it into an object or an instance of that class. So essentially, when you're writing this code and organizing your code into functions and organizing your functions into classes, you're really designing something, right? You're programming something to be turned into an object to be used. So before we create a spaceship object from this class, I want to first add another property and some code to the cruise and thrust functions so that they actually do something. So up here, right below this property, I'm going to declare another name property, and I'm going to assign it an empty string. So you can actually do that. It's a string but with nothing inside, but essentially it sets the data type for this name property. And inside the cruise function here, essentially I want to print out a statement, but I want to include the name. So I'm going to say cruising is initiated for, and then I'm going to insert the name. Remember how we do this? You learned about this a couple lessons ago, I believe, or last lesson. Backslash and then rounded brackets, and you put in the variable name, and it's going to insert that into the string. So we're going to do thrust as well. So we're going to say is, let's say, rocket thrusters initiated for name. All right, so now we can bring this spaceship class to life by creating a spaceship object from it, or in other words, an instance of the spaceship class. And the way we do that is we basically type in the name of the class followed by 2 rounded brackets. So let's start doing that, and you'll notice that autocomplete shows us. So you just press enter, and then you can go ahead and put 2 rounded brackets like that. Now that kind of looks like a function call, right? And just like a function call with a return value, how it returns something to you and you need to capture it using a variable or a constant, the same thing is happening right here. By writing this line of code, you're creating a new spaceship object and it's being returned to you. So you need to keep track of that data using a constant or a variable. We're going to use a variable because I want to show you how we're going to try assigning something else to this variable. All right, anyways, I'm going to call it my ship, and it's going to keep track of that spaceship object that we just created. I want to show you something interesting. Why don't we try assigning another type of data to my ship? For example, an integer, 10. Well, you'll see that we can't assign an integer to this variable because this variable is of the data type spaceship. Well, what do you mean? We went through some data types in lesson 5. Remember, string, bool, int, float, double? Well, as it turns out, when you create a new class, this is now a custom data type. So spaceship is actually a data type. So what you've done here with this line is that you've said, my ship is a variable that can only keep track of data that is of the spaceship data type. So essentially, that's what's really happening here. You're declaring a myShip variable that is going to keep track of spaceship data types, and you're assigning a new object to this variable. So I just wanted you to know that so that it doesn't get confusing otherwise. Now the next thing I want to show you is how do we access the properties and the methods of the newly created spaceship object? Well, we have a reference to that newly created spaceship object from this variable, myShip. And if you've never heard of that terminology before, a reference is essentially what your variable or constant is. It's keeping a reference or keeping track of a piece of data, which in this case is the spaceship object. So myShip is a reference to that spaceship object. All right, so all we do is we type in your variable name or your constant name, or whatever has the reference to that object. Press dot, and this is called dot notation. This is how we are going to access the methods and properties of that object. As you can see, autocomplete pops at this menu, and we can access the name, the fuel level, the cruise, and the thrust functions. And when you get more advanced with Swift, there are actually ways to restrict what can be accessed, but that's for later, for the future. For now, I want to set its name. So I'm going to access the name property, and I can actually say that this name property should keep track of a new piece of data. I'm going to call this ship Tom. All right, so I'm assigning the string Tom to the property name for that object, my ship. And next, I'm going to call, using dot notation, the cruise function. And when I run this code, you can see cruising is initiated for Tom. But had I not set this line, remember I'm going to use a comment here. We talked about comments in lesson 5. That essentially turns this line of code off and treats it as a note or a remark. So I'm going to turn that line off, and then I'm going to run the code again. And you can see cruising is initiated for empty string, nothing. Okay, so that's kind of cool. We could also call myShip.thrust, and we can run that. And you can see, there it goes. I can also just access the properties. I don't have to be assigning things to it. So for example, let's erase these 2 lines, and let's say, let's print out myShip.name, and let's print out myShip.fuel level. So let's run that. You can see it's Tom and 100. I like to think that coding an app is like writing a script for a movie. The movie script is your app code. The character roles are the classes that you've designed, but character roles themselves don't do anything. These roles need to be turned into physical actors and actresses, just like we need to turn classes into objects. Then the actors and actresses follow the script to perform your movie, just like how your objects work together to make your app function. So all of this stuff is pretty abstract, but in the next lesson, we're going to put it into practice. But first, let's do a quick recap of what we learned in this lesson because it was quite a bit. Now, classes contain methods and properties. And remember, methods are just another name for functions. You also learned that classes by themselves don't do anything. They need to be turned into objects first. These objects are also referred to as instances of that class. So remember, a class is kind of like a blueprint, and the object is what's created from that blueprint. You learned how to create a new instance of a class, and you also learned about dot notation, which is used to access the methods and properties of that object. Now, if you need to, I recommend to rewatch this video and ask any questions you have in the discussion area below. I also have a worksheet for you to practice and to solidify these concepts in your head. And if things are still a little fuzzy, and it's completely normal if they are, I highly recommend for you to download this worksheet and go through it. Now, in the next lesson, we're going to use your newly minted Swift skills to bring the war card game to life. Now, if you're excited about that like I am, type in "I'm pumped" into the discussion area below. Hi and welcome to lesson 8. You're almost there. Only 2 more lessons after this one. And in this video, we're going to return back to our war card game Xcode project, and I'll explain to you how those Swift basics you've learned apply to this project. By the end of this lesson, you'll know how to write code inside the view controller to access and manage those elements that we've created in the storyboard. I'll also show you what to do when your app crashes, which is something that actually happens quite often and to all of us. So if you're ready, let's do this. So here I have our war card game Xcode project, and we're going to jump right into the viewcontroller.swift file. Now that you've gone through the Swift basics, we can talk about some of the code in this file. So in this first line, import UIKit, you know what that means. We're basically saying that in this code file, we want to use the UIKit library that Apple provides to make our life easier. If you go down to this line, we have class viewController. So right here, we're declaring a class called viewController, and you can see that it has an opening curly bracket and a closing curly bracket. And this inside is a function. You can see the func there. It's a function called viewDidLoad. Now there are some details that we are going to gloss over right now because it's not relevant for what we need right now. I don't want to burden you with that information, but pieces of information like this here, : UI viewController, essentially this is something that's called subclassing, which is a way for classes to build off of each other. So you're not always declaring classes from scratch. This is essentially saying that the view controller is building off of another class called UI view controller. And this UI view controller class is actually one from UIKit. And for this function here, you can see that there's an override keyword. So you don't need to know about that for now. And also this super keyword, which again is something that we don't need to know right now. But essentially, at a high level, what you're looking at here is a view controller class with a function inside called viewDidLoad. So isn't that really, really cool? Because everything you learned in the last 3 Swift lessons, it directly translates to what you're seeing here. But as you learned in the last lesson, the view controller class by itself is just a blueprint. It doesn't do anything, right? You need to turn it into an object first. So now we're going to jump into the main.storyboard and take a look at the work that we've done here. So all of these elements that we've added into the view here and that we've configured, what are they? Are they objects? Are they classes? Well, believe it or not, what we've been doing here, we've been creating objects. And you might say that, hey, Chris, from what I've learned, objects are created from classes, right? But what sort of classes are these guys objects of? Well, let's take a look at this object library here. You see all of these things? These are classes inside the UIKit library. Yes, that library that we import. All of these useful classes like buttons, text fields, and sliders and stuff like that, when we drag one of these elements onto the view, we are actually creating an object of that slider class or that button class or that UI image view class. And take a look at this. When you click on one of those elements or objects, now that you know what they actually are, and you go here on the right hand side into this inspector, you can see all of these things that we can configure. Well, what you're actually doing is you're setting the properties for that object. So you see everything maps to exactly what we've been talking about in the last 3 lessons. This whole storyboard is merely a visual way for us to create these objects and set its properties. In fact, we could just completely omit the storyboard and we can decide to create all of these image objects, these button objects through code, and then set its properties through code and then put them into the view through code. So you completely don't have to touch the storyboard, but this is more of an intermediate to advanced technique and I wouldn't recommend that for you right now. For beginners, I would definitely recommend to start with the storyboard. So now that you know that these storyboard elements are actually objects, how do we get references to these objects so that we can call their methods and configure their properties through code, through the view controller? Well, that's where IB outlet properties come in. Let me show you how we can expose these objects as IB outlet properties so that the view controller can access them. Now there are several ways to do this, but the easiest way is just to go ahead and select view controller here in your document outline. And remember that this is the visual representation of the view controller object. Click this button here that looks like 2 cojoining circles. This is actually called the assistant editor. And what that's going to do is split your code editor into 2 different panes, a left side and a right side. Now I want to make sure on your right side, you're looking at the view controller. Furthermore, up here in this breadcrumb sort of navigation, I want to make sure that you're, say, automatic here. If it doesn't, go ahead to click it and bring it down from manual or whatever it was set to, go under automatic and select view controller. And then find this spot here right after the opening curly bracket of the class. Press enter a couple of times to create some space. And then on the left hand side, we're going to expose this left card, this first card, as an IB outlet property. Now you could do it through here, the storyboard, but what I would actually recommend is to do it through the document outline. So go ahead and open up your document outline until you see the card here. You can select the element, it's going to highlight the different parts. Make sure you've got that left card highlighted. Hold down Control on your keyboard, and then while still holding down Control, click and drag. This blue line should follow your mouse cursor as long as you're holding down the Control key. Now drag it over here. You should see this little text that says insert outlet. And then you can let go of your mouse button and then control key. You're gonna get this little menu here. And then you're gonna be able to name this IB outlet property. So I'm going to call this the left image view like that. And if you've done this with the right element, the type should say UI image view. If this doesn't say that for you, just click cancel and then try it again. The connection type should be outlet, and you can go ahead and hit connect. And what that's going to do is generate this property for you, because you see there's the var keyword. Here is the name of the property. Here is the data type that this property references, which is UI image view. And this is special because it's got this IB outlet keyword here, which just indicates that this property references an object in the storyboard. Now I'm going to gloss over a couple of things here, such as the weak keyword and this exclamation mark here. So that's not something that we need to talk about right now. But the important thing to note is what you've done here is essentially hooked up that object in the storyboard to this property here inside your view controller. So now that you have a reference to that UI image view object, you can call methods on it, you can configure its properties inside the view controller here. Now, because oftentimes beginners make mistakes when connecting their first IB outlets, I'm going to go through some troubleshooting steps and also some steps for you to confirm that you've done this properly. So go ahead in the document outline for this image that you just connected, right click it, and it should pop up this little menu, and you can see under referencing outlets, it says left image view with this view controller here. Now, if yours doesn't say this, then you might have connected the wrong element. So what I would do is maybe check the stack view. You could have accidentally connected this guy, right click it, and there should be no referencing outlets there. Same thing with the right card view. If you click this, there should be no referencing outlets. If you've by chance accidentally connected another element, here's how to fix it. Go ahead, when you see that menu here, you have to click this little X to break the connection, and then go ahead and delete the property, and then you just start all over. And this time you make sure you have the right element selected, hold down Control, drag that blue line over here, let go, and then you can say left image view. Now let's say when I'm typing this out, I accidentally make a typo and I connect it. A lot of the times beginners will just correct this typo like this and leave it at that, but essentially that will cause a problem down the road when you run your app, because what happens, take a look at this, right click this, and you can see that this image object is connected to a property called left image view with 2 W's. But what we've done here is that we've corrected it. So it's going to look for a property with 2 W's, but it doesn't exist. So your app is actually going to crash. That's not the way you want to fix your typos when it comes to connecting IB outlets. You want to go ahead and break that connection and then just delete the property, and you can start all over. Now I'll actually show you another way to correct this. So the most important part is that you break that connection. You can potentially just leave that IB outlet property that was created, and then you can right click your image that you want to connect to that property. Under referencing outlets, click this little circle, drag to the view controller, let go, and it's going to pop up some properties that you can connect this image object to. Now it's important you don't connect it to the wrong one. Choose left image view, and you can see that this image right here, image view, is connected to the left image view property of our view controller. So that's what you want. Now let's connect the right image view. Hold down Control, click and drag that blue line. I want to make sure that you don't drag it into that same property, because if you do that, you'll be connecting 2 elements onto the same IB outlet property, and that could cause potential problems. So you need to drag it into an empty space where it says insert outlet or outlet collection. Let go. I'm going to call this the right image view, and we're going to connect it. All right, so we've got 2. We're we're going to connect a few more. Let's say we're going to connect the score labels because we're going to need to update them through the code. So let's connect this left player score one, and you can see what I did. I created a little more space there. Hold down Control, click and drag. Call this the left score label. You can see the type now is different. It's a different class, UI label. Connect that. And then here is the right one, right score label. All right. Now I want to show you what an app crash looks like. So I'm going to go ahead and just change the name of my IB outlet property without breaking the connection and fixing it here in the storyboard. And as I told you, this is going to cause a crash. So let's go ahead and run the project and we'll see what happens. All right, so right here, you see this red highlighted line, that's going to be a crash. And we basically see the same thing on the left and right side because we have the assistant editor open. But the main thing is that you need to look down here in the console area. If you don't have this section, just go ahead up here. This will show or hide it. And on this right-hand side, sometimes if you don't have this, there are two small little buttons here in the lower right-hand corner that let you control the left and right sides. So make sure you've got this side here where it shows you all of this text. And down here you see terminating with uncaught exception, and that's just a generic message for an app crash. What you want to do instead is scroll all the way up, and that's where you're going to find an error message which makes a little more sense. So here you see at the very top, terminating app due to uncaught exception. The reason, this class is not key value coding compliant for the key right score label. Now, the line I've highlighted here may not make a lot of sense, but what happens is that once you know how to solve this error, and the next time you see an error message that looks kind of like this, you have an idea about what's wrong and how to fix it. In this particular case, it's telling you that something is looking for a right score label, but it can't find it. And we know exactly what the problem is, right? If we go back into the storyboard, right, this right score label, you can see if you right click that, it says this element is connected to an IB outlet property called right score label, spelled correctly. But if you look inside our view controller, we don't have a property like that. We only have this one, right score lab, without the L at the end. And so that's why the app is crashing, because it's looking to make that connection that we've told it to make, but it can't find, that corresponding IB outlet. So the next time you experience an app crash, and maybe you're looking for help online, or maybe you're in our support forum and you're asking for help, make sure that you scroll all the way up into this console and look for that error message, which gives you a hint as to what's wrong. If you just look at this, it's not really going to tell you any sort of information. Okay, so let's go ahead and fix this by adding that L that was missing. And let's take a look at what we've done here so far. So essentially, let me go back to the single editor view just so you can see a little more clearly. Essentially what we've done is we've connected the two image view objects from the storyboard and the two labels from the storyboard as well as IB outlet properties here. So from this view controller code file, we can reference those objects using dot notation. We can access the methods of those objects and the properties of those objects as well. Let me just demonstrate for you. So inside the view did load method, I'm going to create some space, and let's access the left image view. Now, hold on a minute. Why can we access the left image view from within the view did load method? Well, this left image view is outside of a function but inside the class. So it's inside the scope of the class, remember? This function is also in the scope of the class. So that's why from inside this function, we're able to access that left image view property. Now using dot notation, let's click dot, and here I can see all of these methods and all of these properties of the UI image view class. Let me show you one particular property here called image. Now this image is, you can read the description down here in the autocomplete dialog, the image displayed in the image view. That means that I can actually set this image property to change the image that that image view is showing. Now I'm not going to actually do it, but why I wanted to point this property out is because I want to jump back into the storyboard and show you. If I click this left image view, go over to the attributes inspector here, you see this image attribute. It's basically the image property that I just showed you. See, if I change the card here, right, that's just a visual quick way to do the same thing as if I were to do it here by using code. All right, the next order of business is how do we execute some code when this button is tapped on, this deal button right here? Well, that brings us to IB action functions, and it's connected in the same sort of way as IB outlet properties. Let's go ahead and open up Assistant Editor, and let's create some space here in the view controller side. Now, let me just hide this panel so we can see a little bit more. Now before here, when we were establishing these IB outlet properties, we did it up here. But now that we are connecting a function, we're going to do it down here, still inside of the view controller class. So we have to do it, before this closing curly bracket, but we also don't want to accidentally do it inside of another function. So this is, the opening bracket of the viewDidLoad function, and this is the closing bracket of that viewDidLoad function. We want to do it right here. This is where we can declare a new function. So we can create some space here, like that. Go ahead, hold down Control, click on this deal button element, drag it here, and it says Insert Action Outlet or Outlet Collection. Go ahead and let go, and you can see the action. The connection type should be action. If it's not, just click on that drop down and choose action. And down here, I want you to notice that it says touch up inside. There are different events that this button can trigger. Touch up inside is just a button tap. It essentially means that the user has tapped on the button and then let go of the button while still within the boundaries of the button. If you open this up, you can see there are different events. For example, touch up outside, which is actually tapping on the button and then letting go with the finger outside the boundaries of the button. So that doesn't really count as a tap. So we're going to leave it as touch up inside, and we're going to call this method deal tapped, and we're going to hit connect, and you're going to see that this is essentially a function with this special IB action keyword, which essentially just says that this function is connected to an event triggered by an object in the storyboard. It's got one parameter called sender, which is basically the button. It's a reference to the button that triggered this event. And here is the opening curly bracket, and here's the ending curly bracket. We're going to create some space in the middle, and we're going to add some code to execute when this button is tapped on. So I'm going to print deal tapped like that. And now we're going to run our project, and we're going to tap on that button and just check the console to make sure that this is connected properly. Oh, one thing before we do that, if you've accidentally connected the wrong element, to fix it, you'd go through the same exact steps as the IB outlet property. So you can go ahead and right click the deal button, kill that connection. You can see all of these different events. You kill that connection under touch up inside, delete the IB action, and then just try it again. Just like before, if you've accidentally made a typo here, don't don't just change the function name like that because it's going to break things, right? This is still connected to deal tapped, right? And if you don't have that corresponding function in your view controller file, it's going to break. So just be aware of that. All right, so let's run the project. All right, so we're gonna click, let's move this over here. So here you can see in the console that this triggers. All right, so in this lesson, you learned about how you can use IB Outlet properties to allow your view controller to access and manage those elements in your storyboard. You also learned about IB action functions and how they can be hooked up to events in the storyboard. You learned about common mistakes that people make when they hook up their IB outlets on IB actions and how to correct those mistakes. And finally, you learned about app crashes and how to find the detailed error message when your app crashes. Now, I highly recommend that you try replicating what we did in this video inside your own Xcode project. And if you get stuck or your app crashes, walk through those troubleshooting steps that we went through in this video and you should be fine. Hi, welcome to lesson 9. This is a fun lesson. We're going to make the card images change when we click on the deal button. So if you're ready, let's jump right in. So here I've got our War Card Game Xcode project. I'm looking at the storyboard and I'm going to go ahead and select that left image view. Now in the attributes inspector on the right hand side, I'm going to go to this image property and I'm just going to change it to a different graphic asset by choosing something different in this dropdown. Remember that what we're doing here is just an easy visual way to do the same thing that we could do through code. So essentially when I'm changing up this image asset, I am really just assigning a different graphic asset to the image property of this image view object. Now let's jump into our view controller and see how we can do that through code. Just as a reminder, we have references to those image view objects, right? We have the left image view and the right image view. I want you to also note that the type, the class is UI image view. Okay, that is for displaying images. Let's jump down to the deal tapped method here. Let's erase this line and let's access our left image view. Using dot notation, we're going to access the image property. So hit dot, type image, and this is the same image property we were just flipping around in the storyboard, changing that graphic asset. So to do the same thing through code, we would just assign a different graphic asset to this image property of the image view. I want to draw your attention to one thing here. On the left hand column right here, we can see the data type that this property expects. So this image property expects you to assign to it a UI image object. This is different from UI image view. UI image view is an element that displays UI image data, and UI image is the data that represents the actual graphic assets. So essentially what we have to do here is we have to create a new UI image object and assign it to this image property. So let's just do it, and it'll probably make a lot more sense than me just explaining it like this. All right, so go ahead, hit equals, and then we're going to create a brand new UI image object. Now keep in mind that you have to type it exactly how I have it right here, because class names, lowercase and uppercase do matter. So it needs to be capital U, capital I, and then lowercase MAGE. Same thing goes for these property names. It has to be lowercase I image. So when you're watching me type this stuff out and you're getting errors on your own laptop or a computer, make sure that you're typing the right casing for your property names and your class names. Also, another mistake I've seen is that you have to have spaces, like proper spacing. So make sure that you have a space before and after equal signs, because this is not the same thing. All right, so what we've done here is we've created a brand new UI image object, and we're assigning it to the image property of the image view. However, if we do this, we're really not going to see anything because this is just an empty UI image object. It doesn't actually have any image data to show. So the cool thing about this UI image class is that it's got a method where you can create a new UI image object while passing in some input parameter to tell what sort of graphic asset you want it to represent. So let me show you what that is. So I'm going to open up I'm going to open up the first rounded bracket, and you can see all of these different functions. I'm going to scroll down, or this one, find this one called named right here. And we are going to simply use that one here. Press enter, and we're going to be able to specify a graphic asset name. Now, we're going to choose one of the ones in here. Take note how you're spelling this. If you've just dragged my graphic assets in here, then they should be lowercase c with no space in between the D and the number. So let's say card 5, lowercase card with the number 5. It has to be exactly like that, otherwise it's not going to find that graphic asset. So we're going to type card 5 like that. So why don't we run our project right now just to see that appear. All right, so right now it's a 3 and a 10. When I click deal, it's going to execute this function here, and it's going to it's going to create a new UI image object, grabbing the graphic asset here, and then it's going to assign that to the image property of the left image view object, which is this guy right here. So clicking deal, there, that turns into a 5, which is really, really cool because that's the first time, I think, where you wrote code to influence what happens in the user interface. So awesome. Now we're going to do the same thing for the right image view. Right image view dot image is equal to UI image, right? And we're going to you can actually start typing and it's going to narrow it down for you. So you can choose that. This time I'm going to choose card. I think our upper limit is 14 if I'm not mistaken. Yeah, so we've got up to card 14. All right, so I'm going to run that. And this time, here, let me just put the code on the screen here. This time when I click on deal, we have the ace on the right-hand side and number 5. Now, if I click on deal again, nothing's going to change because it's always just running the same code, right? We need to basically randomize these numbers so that every time we click deal, we get a different set of cards. So let me tell you about how to generate random numbers. It's actually quite easy. So we're going to declare a new constant. Let's call this like left number. And you know the int data type, it's actually got a method called random that we can use, right? And we can specify a range, and we can say the lower range that we have, let's see, is 2, and the upper range is 14. So we want to specify a range between 2 to 14 inclusive. So we're going to go here and we're going to type 2 dot 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 14, right? No spaces like that. And we are going to then print the left number. All right. Now let's do the same thing with the right number. We're going to randomize another one. Same thing, 2 to 14. And then we're going to print the right number. So after you've typed that in, let's run our project. It's not going to change the images just yet, but it is going to print the random numbers to the console just so we can see that we're doing this properly. I'm going to move this over here so we can see. I'm going to click the deal button. Oops, that's still covering it up. Oh, what's it doing? Oh, right here, I've got that little panel hidden. So click on this if it's hidden for you. There we go. You can see different pairs of random numbers generated. Now, the next step is how do we get these numbers into here? Well, all we have to do, actually first thing is let's comment these lines out so we're not printing them out into the console. And I would also want to point out that When you're commenting out lines of code like this, make sure that you clean it up after when you don't need it anymore. So you don't want to leave too much commented code lying around because it can look messy, and it's just not a good practice to keep. Okay, so remember what we learned about inserting variables into strings. So it goes back to that. Instead of 5 here, we want to put left number. So I'm going to erase 5, put backslash, open up a pair of rounded brackets, and insert left number as a variable, right? So the string is going to read card and then whatever left number is. Now I'm going to do the same thing here. Erase 14, backslash, put in 2 rounded brackets, and I'm going to put right number. All right. So let's erase these print statements. I don't think we need that anymore. Okay, so let's run our project here, see if we get the desired result. All right, let's go ahead and click on deal. So yeah, this is really cool. Now, one thing I want to point out is that if you're clicking this, you're randomizing the cards and you're seeing some blank space, like you're seeing a card that's just completely not there, what that means is that it's looking for a graphic asset that doesn't exist in your asset library. So maybe you're double check your range, make sure that you have cards 2 to 14, and make sure that they're named properly. And maybe you might even be missing that graphic asset completely. So check you have 2, 3, 4, 5, 6. Let's check that you have all of them. Because if you're randomizing and you see an empty card, you don't see the image, it either means that you don't have the graphic asset here, or you've spelled it wrong so that when you're trying to create this UI image object, it's not finding that graphic asset in your asset library. Oh, hey, I can't stop hitting this deal button. Now, in this lesson, you learned about how to change the image of a UI image view using Swift code. You also learned about how to randomize numbers and how to insert variables into a string. All right, so remember that you can download the project in the recap notes below. Hi, and welcome to lesson 10. By the end of this lesson, you will have finished the war card game project. All that's left to do is to count the score and to update the label elements on the storyboard. Now, doing this is going to involve writing Swift code that can take 2 numbers, compare them, and then execute different branches of code depending on what the result is. In other words, you're going to be writing Swift code that can make its own decisions. So before we dive into our Xcode project, I want to first start in a playground, and I want to show you what's called an if statement, which is going to allow you to evaluate a piece of data and decide what to do. So the if statement starts with the if keyword, and then you're going to test some sort of condition, whether it's going to be true or false. And so I've got a constant integer, x, it's set to 10 right now. So I'm just going to do a simple check and say if x is less than 11, okay, so that's my condition, it's going to make that test. If that is true, then it's going to run the code in between my curly brackets. So let's create some space in the middle, and I'm going to print hello. And let's run this code here. And it's going to take a while. Okay, so we see hello in the console. The reason this executes is because this condition is true, right? However, if let's say x is 12, and I run the code again, nothing's going to be output down there. It doesn't run this code because it checks and it fails the check. So here's the cool thing about if statements, and that is that you can provide alternatives. So you can say if x is less than 11, then print hello. Otherwise, and you would use this else keyword, and you would specify another block of code to execute. Print goodbye. All right, so if we ran this code right now, what would you expect to be output? All right, goodbye, because it does this check and it fails it, so it doesn't go in there, and instead it comes into this else part. So let me just set this to 10 and show you. So x is less than 11, and that's true, so it comes in here and prints hello, but it doesn't print goodbye. It just chooses one path or the other. Now here's some other cool stuff that we can do with an if statement, and that is to test multiple conditions. So we can say else space if and open up another block. So let's say good afternoon. Oh, I forgot to put the condition here. If x is, let's say, greater than 12, that would print good afternoon. Let's make this number a little bigger. So let's say 15. If x is greater than 15, then print good afternoon. So what if we made this guy 20? So it would basically start at the top. It would check if x is less than 11, and it's not. So then it checks the next one. Is x greater than 15? Yes, it is. So it prints, it executes that code in there, and it skips the else clause. Now, what if none of it is true? So what if I said x is equal to 13? Right, so let's give that a run. It falls down to this else clause because this wasn't true, this wasn't true, so all that's left is this sort of catch-all bucket. Now here's the cool part. You can omit different pieces of your if statement depending on what you want to do. For example, you can remove the catch-all bucket. You erase that and you execute it. Nothing happens in this scenario because none of these conditions are true and there's no catch-all bucket, so essentially no code gets run. Now so far I've just done less than and greater than, but you can also do a couple of different things. You can do less than or equal to, right? You can put an equal sign, or you can do greater than or equal to. You can also do not equal to. So not equal to is actually exclamation mark equals, and that is testing if x is not 11. So let's take a look at this. And we get hello. Now here's a very, very important point, and that is that only one branch of your if statement ever gets executed. So if I had this statement where I was saying, let's say something like that, and I ran the code, both of these conditions are true, right? But it starts at the top, and as soon as it reaches a true condition, it will execute that block of code, and that's it, right? Your if statement is done. So it ever only picks one path to go down, even if this would have evaluated to true. Now this is very different if you write this, because if you did it this way, these are two different if statements. So it would first run this if statement, right, and test its condition to see if it should run this block of code, and then it treats this as a separate if statement, and it's going to test this condition to see if it should run that block of code. So that is one clear distinction to make, right? Doing it like this, if and then else if, combines these two conditions into a single if statement. So it's going to be like two different paths, and it's going to choose one path. Now instead of having two different branches like we have here, you can also do 3 branches or 4 branches. You can just keep chaining these else if things if you want. Something like that. No, that doesn't really make sense, but so you could chain as many of them as you want, but just keep in mind that it's going to start at the top, work its way down, and as soon as it hits a condition that's true, that's the branch it's going to take, and it's not going to execute all your other branches. I wouldn't go too crazy with having a whole ton of else ifs, because there's actually another it's called a switch statement that is more suited if you have a lot of different options. But an if statement is good if you want to just test a couple of branches. And what else can I show you here? So let's talk about the different types of comparisons that we can do. We can do, as you've seen, greater than, you've seen less than, you could do greater than or equal to, you could do less than or equal to, and you can test equality. Now notice that equality is double equal sign. Okay, so this is testing if x is equal to 2. We don't use a single equal sign because remember from your basic Swift lessons, a single equal sign is assignment. If you write this, you are trying to assign the integer 2 to the constant x, right? And this is an error because x is a constant, so we can't change it after anyways. So if you want to compare to see if x is equal to 2, you would use a double equal sign. And if you wanted to compare, if you wanted to test that x is not equal to 2, you would say exclamation equal. And this is testing if x is not equal to 2. Now this stuff can get pretty crazy because let's say you had another constant here, and we're not going to need to do this with our word card game, but I still want to show you, just it's good to know. So if you wanted to test a condition with two different variables, you can either say and or. So and is double ampersand like that. So for me that would be shift and 7, I would get the ampersand, so your keyboard layout might be a little different. So I can say, if y is equal to 5 and x is greater than or equal to 11, then that would be true. Now when you use an AND operator like we have here, both sides of this must be true. Only then will it come into this branch. So if we had something like y equals to 6 like that, we ran this code, then it would jump down to here, right? Because this is not true, and that kind of like cancels the whole thing. The whole thing evaluates to false. On the flip side, let's say we had something like OR, which is actually represented by these two double pipes. For my keyboard, that would be shift and backslash. I get this sort of symbol. So for your keyboard, it might be a little different. But this represents OR. And when you have an OR operator, either this evaluates true or this evaluates to true, and that would be sufficient for it to go down this path here. So as you can see, if I run this code right here, we're going to get hello. And that is because even though this is not true, this is true, right? And that's enough because we're using OR. Now here's the crazy part, and that's that you can use brackets to chain these things together. So you can do something like this. So you can say like, if x plus y is equal to 10 and either this one or either this one is true, then come down here. So you can express some pretty complex logic depending on where you place these brackets. So let's try to run this code here, and we get good afternoon, but how will we make this work? So x and y have to equal to 10, y has to equal to 6. So if we just did that and we changed this to 4, that would actually bring us into hello. So why does this evaluate to this branch? Well, because x plus y is equal to 10, right? Is it? 6 plus 4 is 10. And because we're using the AND operator, this side must also evaluate to true. Now, what does this side say? Well, since it's using an OR, either this must be true or this must be true. So x is not greater than 11, right? It's 4, that fails, but y is equal to 6, so that's true. So essentially this side is true and this side is true, and so that's why we're going down this path here. So now we're going to implement an if statement inside of our Xcode project. Now let's look inside the view controller.swift. Inside the deal tapped, we so far have been changing the image, but we have all the data we need to determine if the left side is the winner or the right side is the winner. See, we have left number and right number, right? And based on what you've just learned on the playground, we can just compare these two numbers. So we can say if left number is greater than right number, then left side wins, or player wins, right? Else if right number, let's actually keep it consistent. So left number is less than right number, then we have right side wins. And then we do have another scenario, right, where left number equals right number. So we can just use an else, and we can say tie. Now I'm not going to address this particular scenario because I'm not exactly sure what to do, but if either the left side wins or the right side wins, we can increase the score and then we can update the labels. So if you remember all the way up here, we actually haven't declared any properties to keep score. So why don't we go ahead and do that? Var left score is equal to 0 and var right score is equal to 0. So they both start at 0. You scroll down here and we're going to say left score, and we're going to use plus equals 1. Essentially that takes whatever number is currently inside left score, and we're going to add 1 to it. And we're going to then assign, or rather update the label. So we do have a reference to the label because we have an IB outlet property called left score label. You can see it's a type of UI label. And if we use dot notation, we can access the properties and methods of that score label object in the storyboard. And it actually has a text property that expects a string. So we're going to assign a string to it. The problem is that left score is an integer. So if I try to put left score, see it's an int. If I try to assign left score to update the text of the label, we're going to get an error because it says it cannot assign a value type of int to a type of string. Because remember that the text property is expecting a string data. So what we can do is we can actually create a new string object like that, and it just has a special way where you can pass in an integer and you can represent that integer as a string. So that's essentially what's happening here. We are creating a new string object and we're passing in this integer, and it's going to essentially treat that integer as a string or change or convert that data type. Now let's do the same thing with this side. So we're going to say right score is plus equal 1, increasing that score. And then we're going to say right score label dot text is equal to new string object, and we're going to pass in right score. All right, so let's run our project now and just take a look at what we've got. We've got our card game here, and king is bigger than 3, so we have that increased score. 9 is bigger than 7, so we have 2 now. Gets 1 on the scoreboard. Ace is bigger than queen, so you know, cool, works. Now don't forget to go back and write yourself some comments. Get into the habit of doing this. So we've got randomize some numbers, update the image views, compare the random numbers. And you know, you can get as granular as you want with this. Yeah. Now the last part I want to show you is about running this app on your own phone. So in order to do that, you would just plug in your phone with a cable, plug it into your computer, and if it's the first time you've ever done this, you'll probably get a pop-up, like if you have Xcode open, asking, do you want to use this phone for development? And you have to click yes. When you do that, it's going to set up your phone for iOS development so that you can run this project on it. And also, if it's the first time you've ever plugged in your phone or your iPad to your computer, it's gonna ask on your phone, do you want to trust this computer? And you have to click yes or trust, whatever shows up on your phone. So those are the two things that have to happen. And then once you do have your phone connected and it's got the proper permissions and everything, if you pull this drop down, you're going to see here, I don't have a device connected right now, but you're going to see your device here. It's going to be like your name, whatever you've named your device, essentially. You're going to see it here. You're going to want to choose that. Okay, so this pops up for me because I don't have a device connected, but you're going to want to choose that and then you're going to want to just click run. And essentially, instead of launching the simulator, it's going to launch this app on your phone. And then after that, you can stop your project, disconnect your phone, and you'll still have that app on your phone. Now, the thing is, when you do it this way, Apple intends for you to do it only for testing purposes. So I think it gives you about 7 days before it won't launch anymore, and you're gonna have to connect your phone again and kind of like run your project on your phone to give you another 7 days. If you do have an Apple developer account though, and this is like a paid account that Apple charges you a fee every year for you to publish apps into the App Store, then you'll be able to keep your app on your phone for a lot longer. You'll also be able to send that app to other people's phones for testing purposes, and also to publish apps into the App Store. Not bad, right? Look at how far you've come. Seriously, give yourself a pat on the back. You've just gone through 4 hours of iOS training, not including the exercises, and you've built your first app that you can show people. To celebrate this huge milestone, I want to give you a certificate of completion. Just visit the link below or check out the description and get your certificate and get your name up there on the wall of success stories. Now, in terms of what to learn next, I have several options for you. Number one, you can visit youtube.com/codewithchris to see all of the other free content and tutorial series that I have that you can watch. Number two, if you have an app idea, make sure you go and get my free 7-day app action plan, which is going to help you put together an actionable list of learning objectives to build your app. You can get that by going to codewithchris.com/action plan. And number three, if you have some budget to spend, you can check out my paid courses, which actually continue from the 10 lessons that you've just watched and continue building your skills and building apps. And to check those out, visit codewithchris.com/beginner course. And lastly, I just really want to thank you for learning with me. You know, I never imagined myself teaching iOS, but I'm having so much fun every day, and I feel so fulfilled hearing your success stories. So if this training has helped you out in any way, please reach out and message me and let me know. If it weren't for people like you, I wouldn't be here today. So thank you again.